Okay, guys. So good morning, everyone. So let us continue our scripting, advanced shell scripting day 3 session. So today is a day 3 session, and today is 16th September 2023, and today is day 3. Okay, day 3 is first session. Because we'll continue our session today, right? The second session also. So the timing is 6:10 a.m. IST time. Guys, last week we had started this course, right, where we covered around 5 sessions, right? And in the last session, we emphasized more on understanding about what exactly the shell, right? So we firstly we understood about what is an operating system is all about, right? And what are the different components of operating system, right? Why do a operating system exist, right? Because whenever an application want to communicate with the hardware, it can communicate only with the help of an OS, operating system. Without an operating system, right, any application or any command or any user cannot communicate with the hardware. So there has to be an interface. So OS is a set of program, or it's a set of models that controls and coordinate the hardware resources for the different application program. So that's how we started our journey in understanding what exactly an operating system is all about, and what are the different subsystem of the operating system. There are 5 subsystems, right? And then like we got into understanding about what is the user space and kernel space. We understood, like everyone understood this about this user space versus kernel space, right? Why we have this concept all about, right? So like whenever we boot up the system, right? So the RAM memory, or we call even the RAM memory, even we can call it as a physical memory, right? Some people they call it as a virtual memory. Yeah, virtual memory also do exist in the RAM itself, but as of now, we will not call it as a virtual memory. We call it as a primary memory, or but physical memory. So your entire RAM memory or the physical memory, it gets divided into 2 spaces. And usually what happens in the user space, where user will log in, or where a user logs in, or where any user space process will run. And in the kernel level, or in the kernel space, where the kernel will be up and running, or your operating system will be up and running. So guys, if I say operating system or the kernel, if I say operating system or kernel, it is all one of the same. Both are same. We never call it as a Windows, we never call it as a Linux OS. No, we call it as a Linux kernel always. So we always use the term kernel always. So kernel is also one of the, like the name given by the open source community. Okay, kernel, right? Kernel. So kernel is your main core of your operating system, or we call it the main heart of the operating system. 90% of the job of the operating system is done by the kernel. Now, after that, after discussing about all these things, what we discussed is that we discussed about something known as a shell. So what is a shell? Shell is nothing but it is an interface between a user and the kernel. So whenever a user he want to communicate with the kernel or with the operating system, he cannot directly communicate with it, right? Because kernel works in a protected mode. Kernel has its own routine to work. A user space program or the user, he cannot directly communicate with it. So there has to be something in between where using that he can communicate with the kernel, and that is why with the help of a shell. So user will communicate with the shell, and shell will communicate with the kernel at the end. Like this, the communication happens, right? And we discussed many other things also, right? How exactly the shell internally works, right? What exactly shell does, how we are going to get the shell, right? As soon as we log in, we'll get a terminal, and the terminal is attached with the shell. That's what we discussed, right? After this, what we discussed at then, do you remember what are the things we discussed? We discussed about the file system also, very basic understanding about what is the file system is all about. So file system is not but your inverted tree structure, right? Where the top of the file system, the root of the file system is slash. And below the slash, we'll have many other subfolders or directories. Like we have a bin directory, sbin directory, root directory, dev directory, etc directory, var directory, usr directory, temp directory, opt directory, sys directory, proc directory. Like that, we discussed many of the like the subfolders or the folders which come below the slash, right? And also we even discuss about how to create a server. Like we, so what I did, right? I logged into my AWS account and I try to create these two servers because I want to showcase something on both these servers. Like we have a CentOS servers and we have a Ubuntu servers, right? CentOS is basically, it is a from the Red Hat company, right? So because RHL is a proprietary one, you have to give the licensing cost to get the RHL. So that's the reason what happened, that some people don't want to go the RHL, or they can't experiment everything in RHL because it involves a licensing cost. I have to give the money to get it. So that's the reason what happened. The Red Hat, what they did, right? They had come up with the CentOS operating system, which is a free way of operating. It's a free operating system. So you can actually, you can install the CentOS in your virtual box machine or in your laptop on your, or in your machine, and you can start working on it. It is like a ditto like an RHL, or it's ditto like a the paid RHL softwares, right? Distribution, right? It is same as that actually, right? But the problem with the CentOS is that CentOS doesn't give any kind of a support. CentOS might have some kind of a bugs. When a user is working on the CentOS operating system, he might come across a lot of bugs, but there'll not be any support for them because it's an open source. It's a free version given by the Red Hat. Whereas an RHL, if you go with the RHL, if there is a bug or if you are having any issue working with within that operating system, the Red Hat company is there to support you because you have paid the money for the licensing cost. So you'll get a 1 year or whatever the 6 months uh, support is there, right? That you're going to get it. Whereas at CentOS, you won't get it actually. And there is no guarantee that whatever the bugs you come across, whether you will get a fix for that or not. There is no guarantee. But whereas a Red Hat or the RHL, Red Hat Enterprise Linux, right? That has a support actually. So that's the reason most of the companies, corporate worlds, companies and all, they go with the Red Hat actually. And Red Hat, as I said, it's a most favorable, like a kind of a Linux distribution used across many companies actually. And as you know, that Red Hat company was acquired by the IBM, right? Like if I'm not wrong, like 7-8 years back, it got acquired, and now Red Hat is a part of IBM only. Okay. So apart from this, we will be using, or we'll be using even a Debian Debian-based distribution operating system, which is nothing but the Ubuntu server or the Ubuntu distribution. Why I'm saying, because these are the most two important Linux distribution Linux versions are used in the industry. You might see in many organizations they will be using Ubuntu servers also. So in our company also we are using Ubuntu servers. So Ubuntu servers are all open source free versions. Yes, you have some of the paid version also, which is about the Ubuntu server editions. You'll get it where you need to pay the licensing cost. But whereas most of the people prefer to go with the Ubuntu free version only. So again, in Ubuntu, you have very different flavors of Ubuntu are there. Yeah, like Ubuntu, K Ubuntu, U Ubuntu, P Ubuntu, like that. Different flavors are there. But we are not going with all those things. We are just going with the Ubuntu, and the latest version for Ubuntu is 22.04. So latest version of the Ubuntu is 22.04. So we would recommend to go with creating a Ubuntu server with the 22.04 version itself. So this is what I would recommend to go with this. Similarly, for the CentOS, you can either go with the 7.8 or 8 version. You can go with any one of this, and you can start working on the system. Some people might use CentOS 6, some people might use a very older version, some people might use Ubuntu 18.04, right? Those are very older version, like 6-7 years back older. Those versions had come at the time, but I would recommend to use always the latest version. So guys, this is what we had covered. And in between, we had even executed some commands also. You know that I was executing some commands, because everything in Linux or Unix is a command only. Because ultimately at the end, right, the user have to start executing or working on a system with the help of a commands only. We had just executed some commands. As I said in the last previous session, that I'm not really going anything with the commands, because when we start the command set, we have to start from the very beginning, the commands execution. So just to showcase in the class that, yeah, you need to understand some concept of operating system or about the Linux, you can understand only not many times you'll understand only while executing some commands only, because when you execute a command, you'll get output. And once we are understanding that output, we are actually understanding about the system itself. So that's the reason what happened, right? Executing the commands and explaining the concept of the Linux operating system, everything through the commands is very, very important, because through commands only you will be trying to understand many concepts about the Linux operating system, right? Without commands, it will be very difficult to explain everything, because when you see the output, right, you can correlate whatever we are explaining the concept, right? You can correlate with the output of the command. So when you relate with, you will better understand, okay, in this particular way only the system works actually. Clear? The same thing is in Windows also. Windows also, whenever any person is learning the Windows operating system concept, right, you will try to install some software and you will try to execute some command in your PowerShell or in your command line, right? You see the output, you understand the concept of that Windows operating system through the output of the command. That's how. It's a common case. It's not like that. So it's very important to understand all the commands and everything. That's what we had discussed, right, in the last session. Clear? So this is what we have covered till now. Many of you have gone through the whole video again. I hope that you all have gone through all the 5 videos. So if you have any doubts, please ask me now. Sorry. Good morning, Nikhil, Niranjan. Any doubts you have, guys? Sarvanan from the last session. No? Okay.
No, sir. So far good, sir.
So far good. Okay, good.
Thank you.
Okay. Sure. Now, so let us, what we are going to do now, let us understand some more things about the shell, right? And we will try to understand about what are the shell features, right? Why, what is nothing but the login shell, non-login shell. These are some of the very important things which we have to cover. Okay, very important. Now, so let me open MS Paint, guys. In the last session, again, the same old diagram. You have this RAM memory. This is a RAM memory. And during boot up time, the RAM memory will get divided into 2 spaces. Right? So this is nothing but your user space. And this is the kernel space. We have seen this already. Sorry. Yeah. We have seen this. And in your user space or in the kernel space, sorry, the kernel will be up and running. Kernel will be up and running. Right? And we also saw in the last session that whenever we are booting up the system, right, booting up the system, you will have something or /boot partition. In that /boot partition, we saw that there are 2 images are there, VM Linux image and the init RD image. Init RD image. These are the 2 important files which get loaded into the memory during boot process. This is what we learned, understood, right? So VM Linux is nothing but your actual kernel image, which will get loaded into the kernel space of the RAM memory. So this is nothing but your actual compressed image, kernel image, which get loaded and which will get uncompressed during boot up time, right? So uncompressed means this will be kind of a into the tarball. It will be the uncompressed image. And once it gets uncompressed, the initialization of the operating system or the kernel happens, and a lot of different services will get started, and finally your kernel will be up and running. This is what we said during boot time. This is what it happens. Init RD is nothing but your root file system information image, right? Root file system. So in the root file system, what happens that you have your slash, right? So here what happened, the init RD image will be loaded here actually into your what? Into your user space of your RAM memory. Yeah, I think. Yeah. Init RD image. And this init RD image, that's what we call it as a root file system. This also we discussed at the last session. Root file system. So once this get loaded, guys, into the user space of your RAM memory, so this will get extracted, I said. It will get extracted with the help of a cpio command. So once it get extracted, what happened, right? Your root file system will be loaded into the memory, like something like this. Slash will be your ultimate parent directory, like this. And then like here you come like this, and you can see that there are so many different subfolders within a slash will come, right? Like for example, boot will come here, bin will come, right? We had discussed about all these things, guys, last class, right? Like this slash. So this is the ultimate file system, whatever is there, right? This will be loaded into the RAM memory. Boot, dev directory, right? And then like you have a lib directory, you have a etc directory like this. And we have a many other home directory for the normal user, right? So like this file system will get loaded. So this file system will literally be present in your user space. So whenever a user logs into the system, he will be a part of the file system. He will be working under the file system only. Clear? Now, what happened, right? This is a whole file system itself. And this is nothing but you can consider slash as a root partition, or it's a root partition. It's a root partition where the root, where what happened, right? It is not but your root file system, we say. So ultimately, your file system will start from the slash itself. Slash is the ultimate parent directory. Like similarly, slash is same as your C drive. Whatever you have a C drive, right? Slash is the same as your C drive, what you have in Windows. What happened, man? It is same thing like your. One second. What happened? It is like a same thing like your C drive actually. So now that's how it is. And when a user logs in, say for example, we have a user in our system, we have seen that we have a user like Ubuntu user. Today we are going to create some users, definitely. Ubuntu CentOS user, suppose a user by name Kiran is login. Any user who is login, right? They will always sit under the home directory within the file system. So as soon as they log in with, they will get a shell actually. This is what we had discussed. So they'll get a shell like this. If Kiran logs in, okay, if Kiran logs in, Kiran will get his own shell he will get. So now the question comes, are each and every user, does he have his own shell? Yes, he will get his own shell actually. He'll get his own shell. So here what happened, right? As soon as a Kiran or anyone log in, right, he will get his own shell. This is what, again, we had discussed the same thing in the last session, right? He'll get his own shell, and the default shell, right? The default shell is nothing but your bash shell actually. So bash is a default shell. BASH, born again shell. Bash is a default shell, what will get it. So whenever a user logs in, he will get his own shell. And this is a shell through which the communication happens between the user and the kernel. So /home /Kiran. Suppose Kiran is logged in. I'm just taking an example actually, right? Kiran has logged in. So Kiran will be sitting at the /home Kiran. He'll be sitting here and he will get a shell, actually, his own shell. His own shell. He'll get his own shell. So he will try to execute some command, like he will try to execute some commands like ls command, date command. He will run some application sitting here, right? Now what happened, as soon as he's executing any commands, right, he's actually communicating with a shell, bash shell, and the bash shell finally will communicate with your kernel. This is how it happens. Sometimes some people say that, sir, his bash is a process itself. Yes, it is a process. Okay. He is a /home Kiran who's logged in. He himself is a process. Yes, he's running as a process only. Yes. So kernel is also a process. Yes. So in a whole system, in our entire operating system or in your whole entire system, is everything is a process? Yes, sir. It is everything is a process. A user logs in, he is also a process. A shell is also a process, and kernel is also a process. Everything process to process communication is happening like this, right? Right. So here what happened that user logs in, like I'm just taking an example of Kiran. Kiran is logged in. Kiran himself is a process who is running in a system. Even though he's a user, he himself is a process who is running, right? And here what Kiran is doing, Kiran is actually communicating to the shell. Shell itself is a process, again in a system. And the kernel finally, through which the shell is communicating, kernel is also a process. Oh, it means that process to process communication is happening in a system. So everything in operating system, everything in operating system is process, right? So do you agree with this statement, guys? Everything is a process. There is nothing without a process, nothing happens. A process you want to do, you want to achieve any task or you want to do any operation into a system, it has to be a process at the end, right? Process has many other information, how process will get created and all. We will discuss in very in detail later after some point of time. We already discussed in the last session also, like whenever a process has to be created, a fork system has to get called and all. So in a very high level we discuss, but we will discuss about whenever we come across with the process management, right, in our upcoming sessions. So we will discuss about this point very effectively, like what is a process, what is a process holds, right? How you can what are the different states of the process, that is also very important. How the process to process communication happens internally, so many things are there, we will be discussing those things. Okay, but now try to understand that everything is a process. Good, right? Now, so as I said, right, like whenever we are executing any command or any application, a process has to get created. So who will create a process? The kernel or the operating system will create a process, right? If you remember, I had given example of this Google Chrome. When I do a double click on the Google Chrome, this Google Chrome browser will be launched. But how exactly this get launched, or how exactly this Google Chrome browser is getting opened? This is getting opened because that there's a process which has got created. Who will create a process? Your operating system or the kernel will create a process. So for every operation, guys, there has to be a process. Without a process, nothing will work. A process has to be there. System works, or your operating system or your kernel works with the help of a process. Clear? Okay, good. Now, so now when we talk about this shell, so as I said, that shell is nothing but shell is an
Hello,
interface between the user.
hello, sir.
Yes, madam.
Hello, sir. I have one doubt. Boot home, these all are directories, and these are the directories of Ubuntu operating system, right?
It's not only Ubuntu. If you take any Linux operating system or you take any Unix operating system, everything, all are same only, madam. The root file system is same across any operating system, right? Then you might get a doubt or you might ask a question. Then so why we need so many flavors, sir? If that is the case, everything is same like that. Even our traditional Unix operating system also has the same file system. Slash is there, below that boot is there, Dave is there. It's the same thing. So file system, what Linus server did that, he tried to, take the same idea, whatever you had a traditional Unix operating system had, right? Which was designed by Ken Thompson and Dennis Ritchie, right? The same file system was even tried to not copied. The same idea was took from the Unix also. But what Linus Torvalds did that, Linus Torvalds enhanced it. He didn't kept there itself. He didn't just try to take the entire thing and implement it. Right. If that was a case, if he had did it, it means that you can call it as simply like a copy. He just copied the idea or he copied the same thing and pasted here. So then what is the difference? No, it is not like that. Linus Torvalds, he took a lot of ideas from the Unix operating system, but what he did, like he had enhanced a lot of features. Even in the file system also, he enhanced actually. So even if you remember, like in the last sessions, in one of the session, I had told that there are many file systems are there there are many file systems which exist, right? You have a ext3 file system, ext3 file system, razor file system, or else you will have a hpfs file system, coda file system, andrew file system, that even called the afs, nfs file system, proc file system, some special types of file system, right? So many file systems are there, but Linux supports almost all the file systems. How it supports almost all the file system? With help of a concept known as a virtual file system layer. So that is a software layer which is present in the kernel. Because of that, the Linux system or the Linux kernel can support n number of different types of file system. There are around 38 types of file systems are there, guys. Almost all the file systems are supported by Linux itself. How it is supported? With the help of a concept known as a virtual file system. Now you might ask, sir, who designed this virtual file system? It's a Linus Torvalds who designed this. So this is a new feature? Yes, this is a new feature, guys. This is one of the new feature which will make a difference from your older Unix machine to your Linux server, actually, Linux machine. Similarly, you have a different flavors of Linux are there. Like you have a Red Hat, Ubuntu, Kali Linux, right? You have a Debian, you have an Opix, right? You have a Bluefish. Like that, there are many distributions are there. Now, if you ask, sir, every distribution, it's the same file system, the same kernel, then why we have so many different distributions altogether? No, every distribution comes up with its own flavor. Every distribution add on their own, like applications or the server applications that might differ from one distribution to other distribution. Right? Red Hat is most favorable. Why? Because Red Hat supports a lot of server editions. So when it comes to server level, where the companies want to adapt for installing any server related package or server related services, they'll go with the Red Hat because Red Hat or RHL, they are very favorable in that. Similarly, what happened like when you go to the SUSE has its own flavor. Ubuntu has its own flavor. That's the reason, guys, there are multiple distributions are there. So based on your requirement, you can go ahead and you can purchase any of the distribution. Either it could be an open source or either it could be a licensed version. You can go with anything. Clear? But the concept is same. At the end, no, everything is looks same. Right? It's not like that it differs. File system differs. No, they cannot do that kind of a changes. A distribution cannot do. They can actually tweak some features in the kernel. Suppose they have this kernel, they can go and they can tweak. Tweak means do some modification changes to the existing kernel, but they cannot do the changes to the core part of the kernel. No, they cannot go and do the changes in the network management. They cannot go and do the changes into the memory management of your kernel. No, they cannot do that. Distribution will not do that. Because if they do it, actually, what happened, right? It is no longer called as the release version of the kernel, which is released by the Linus Torvalds or its teammates. No, you have freedom. You want to tweak the Linux kernel also, because the Linux kernel ultimately everything is an open source only. Right? Any distribution or even you being an end user, you can take the kernel, you can do changes according to the requirement, but there are some main components are there, like the main core stuffs are there, which you cannot change. If you change it also, you need to change under some licensing, like GPL licensing, we say, general public licensing. That is a licensing which is provided by your open source community, GPL, general public license. So through this general public license, you can actually change the component of the kernel. But again, anything is messed up, nobody will support you. You have to fix your own, actually. That is the thing. So now, so coming back to our main, this one here. Now, so shell has created, like as soon as the user logs in, shell has created. And the shell here is nothing but, it is an interface between the user and the kernel. Right? Shell is an interface between user and kernel. And the bash is a default shell. Bash shell is a default shell. Default shell in Linux operating system. This we know very well. Okay, and how to check in which shell you're working under? You have to execute command echo $SHELL. So if you execute this command, you will see that it will show the output as a /bin/bash. So guys, can you log into the servers? Yes. So the last session, we had created these two servers. So let me first log into CentOS. Click on this CentOS, copy the public IP. Okay, I go to your downloads where I have the putty. So open the putty software. Just click on this because these are settings we had created last class, right? Load this CentOS at the right and then like paste it. Okay, and then open this. Accept the connection. So now you are able to log into CentOS. You could see that CentOS has logged in. Correct? Now, similarly, I will try to log in even to the Ubuntu server. Click on this Ubuntu where you'll get the public IP address. Copy the public IP. Go to your downloads where you have putty. Click on the putty. Load this Ubuntu. And here, you know that this is the two sessions we created. And just paste it. The public IP of your Ubuntu server. Open it. Accept the connection. then it will log into the system. So this is nothing but your Ubuntu server, like this you have to understand, and this is nothing but your CentOS server. How to check whether it's a CentOS or whether it's Ubuntu, cat etc. There is a file Red Hat has released. If you execute this or if you open this file, you will see that this is the Red Hat CentOS distribution, right? The CentOS distribution. Similarly, you go here and you do a cat of etc lsb release. So this is not but Ubuntu 22.04. The distribution code name is Jammy, and it is the whole description is Ubuntu 22.04 LTS. LTS means long-term support. LTS we say long-term support. Copy this. I'll paste it here. So what I will do, guys, whatever the commands which I'll be executing or some important commands, right? I will try to copy paste in a notepad so that will be a reference for you. Clear? And also, as I said, right, you have to create these two servers, guys. Either it could be in Azure or either it could be in AWS or even in your local laptop itself. If you have installed the Sun VirtualBox or VMware virtualization software, right? You install it, and then on top of that, you can create a Linux VMs actually, and you can start practicing. So I would expect that everyone starts practicing from the day one onwards. Don't delay in practicing. Don't say that, okay, I'll practice after some time or something. No, that is a wrong thing where people get into it, that they don't practice a lot actually. Practice is very important. So now once I log in, as I said, right, I'm going to get a shell. How to understand on which shell you're working under? Capital SHELL. So this is the command actually, right? If you execute this command, the same command is there even in Ubuntu also. So most of the time, 99% of the time, guys, whatever the commands you execute in one distribution, the same command will always even work on even the other distribution also. It doesn't mean that no, it is completely different. No, it's not like that. Now, the stuff is that actually some people have some confusion, sir. Like I'm working all these years, I'm working on CentOS, sir. Suddenly, if I go to some other company, there I might use some other distribution. Is there any difference, sir? Working from one distribution or other distribution, or else whether I feel comfortable working on that, or what is it? So, and also like suppose I'm executing or I'm writing some scripts in one distribution. In other distribution, can we put the same scripts there also and run it? So some people have this kind of a confusion. So what I would say you that, guys, there is no difference at all. If you're working on a Red Hat distribution for some years, and if you go to any other organization or you come across with some other project where you need to use on Ubuntu, right? It is not that difference, right? Maybe some configuration files may differ here and there, configuration files, but the command, 99% of the commands are same only. It doesn't really make any difference. So don't worry about that part. Don't think that, yeah, some configuration files, some configuration files might change. Some configurations file path might be changed. Some commands path might be changed. It might in your Red Hat, that command might be in one path, but in Ubuntu, the command will be there, but that will not be in that path. It will be in some other path. For example, you might say that, sir, the ls command in your CentOS is there in bin directory. I'm just telling you. Whereas in Ubuntu, it is /usr bin directory. So the path of the command where it is also placed might be differ from one distribution to other distribution. So configuration files and everything will differ. So and also like you might say, sir, here I'm working on some servers, like for example, in Linux, Red Hat Linux, I'm working on some Samba servers, where I have some configuration files, where there is some configuration settings are there. What about same thing if I want to configure the Samba server in our Ubuntu? Whether it's the same, sir, it might differ slightly here and there, but that will not be that much major that you cannot understand, or if it is a completely different concept, it's not like that, guys. It will be more or less same. So whenever you are trying to understand any one distribution, please understand in a very in detailed manner, so that when you get a chance or opportunity to work on some other distribution, you will start comparing everything and learning. So that's the reason. So when I started my career, right, I was working on RHL 5 actually. So RHL 5 was very, very robust operating system, and it is a Red Hat, right? And I was working under that. I learned everything, and finally, after some point of time, I shifted to Ubuntu. So Ubuntu, I found it out more interesting. But when I was working Ubuntu, I could see there are a lot of differences are in the configuration files also. Though commands were same, but the configuration changes were little bit different. So it took hardly some few, hours to understand me. It's not like that, like it is completely entirely different. No, I went to the Google and I tried to go understanding about that particular server or Samba server from the Google. I went and I tried to understand how to configure the Samba server in Ubuntu 22.04. I got articles. I was reading it, but I already knew about the Samba server, how it works in RHEL sub 5. So understanding the same thing in Ubuntu, it doesn't make that much change. Here and there, some configuration will get changed. The name of the configuration file also will get changed. Even the path of the configuration file also will get changed, differ. But ultimately, the concept is same. Is it clear, guys? So some people have this confusion. Same thing when it comes to scripting also, it doesn't make any difference at all. You work in one distribution, the same script will work in other distribution also. It doesn't make really much sense. It doesn't really have much differences. Is it clear for you all? So some people have this doubt. That's what I thought I will clarify this. Okay. Clear? Okay, good. Now, so as I said, guys, some of you have newly joined. Please unmute yourself and ask me any kind of questions. Okay. Don't go without understanding anything. Please don't go. Right. Always, whenever you get any doubts, please stop then and there itself. My humble request to everyone. Okay. Now, so this is the command, guys. When you execute this is a command. So you might see that, sir, what is this capital SHELL? What is this dollar? What is this echo? We will come across with everything today itself. Okay. What is it all about? Now, after that, now what are the different shells where the Linux supports? There are various shells are there, guys. Like if you execute the command, or if you open a file, cat etc shells. If you open this file, right, it will show you what are the different shells where your Linux supports. So right now you could see that it supports /bin/sh /bin/bash /bin us /user bin bash /user bin bash. So these are some of the shells it supports. The same thing can go over here and do it cat etc shells. See, now you could see that you have many other shells. Like for example, you have a r bash shell, dash shell, ash shell, tu mx shells. So you could see that there are many other shells which are there, which are supported by your Ubuntu, right?
Hello. Excuse me, sir.
Yes.
Sir, when we type like echo dollar shell, why only bin bash it is showing, sir? Why not all like?
Because this current user, he is working under the bash shell.
Okay.
If you see it here, cat of etc possibility file. Can you see there's a Ubuntu user here?
Yes, sir.
Can
Yes,
you
sir.
see he is working under the
Yeah.
/bin/.
Okay, sir. Got.
Similarly, here also, if you go here, cat etc else 6, sorry, cat etc possibility file. Can you see there's a user by name CentOS? He is also getting a /bin/bash. Can you see the Rajesh user? He is also getting a /bin/bash.
Okay, sir. Got.
Right. So Rajesh user I created last time. Now you could see that I can even log in as a Rajesh also. Right. How to log in it? We'll see it now after some time. So Rajesh is a user account I created last class, and I think I remember a password I gave is 123 is a password I gave. So if I give Rajesh and give the password 123, I will log in. I will get a /bin/bash. Okay, good. Good.
So Rajesh, we cannot create any users in the root directory outside. Means we can create the users in the outside, no? Outside of the bin also. Is it possible?
Users are always created under the /home directory. This is the default directory where user accounts are created.
Okay.
But there are commands are there, or there are options are there. Through that, what happened? Instead of creating under the /home directory, you can create your own user account from the / also. You might have seen in my previous organization. Okay, my ID, like my login ID was this is the ID username, or this username was this. This was my ID actually, and the password I had given something 123 password something. Okay, so I was logging into some servers there in the companies like LXO, VT, ecom 00.dev.printer.com. This is a server which was there. So now what happened, right? As soon as through the putty, I used to copy this LXO MVT ecom, the complete one. I was logging in like this actually. Through the putty, I was giving this username, so the host name I was giving. So once it's given, right, it asked me for the username. I used to give the username as 80392 and the password as 123. I used to give. As soon as I log in, I used to log in this server. Now, after I log into server, when I do a PWD, right, after logging to server, when I executed the command PWD, it was showing me like this actually. Now you might ask, Rajesh, you said already that whenever you log into the system, that particular user will go and sit under the home directory. Yes, actually it should be like this actually, right? But you logging in here. Similarly, guys, many of you, if you're working in a company and you log into some Unix machine or Linux machine in your company, okay, when you log in it is 100% always that you'll be logging under a home directory only. But sometime what happened, you will see some other path apart from /home. It is some other path. Now you might get confused. What is this, sir? Then, so this is the /u is a home directory in this server, right? Whenever user logs in, he will be logging under the /u itself. Then what is the /u and /home? Nothing, sir. This is just a folder, sir. Don't get confused. It's a folder, sir. Like how /home is a folder name or a directory name. Similarly, /u is a folder name or the directory name which is there under this server. Why did this like this? Why did like this? They could have kept a /home only. Yeah, they could have kept on a /home only. Sometime what happened, right? The home directory will be in a completely different path, or the home directory will be in a completely different partition. They would have renamed the name as a /home to some other name. So is it possible like that way, sir? Yes, it is possible. Why they do like that? Yeah, for some reasons they do like that actually. Who will do all those things? The system admin or the administrator who's managing the server, he will configure in such a way that whenever the user accounts are getting created, will get created under the /u in this case. Right? So sometime what happened, right? Kiran will log in some server in his company. He will log in. He will directly be login like this actually, /Kiran. Now you might get it out. What is this, sir? You said about /home Kiran. I'll always use /home Kiran. No, it is, yeah, that is the by default nature of the Linux that when you log in it, but it is configurable also. It means that the system admin can configure such a way that you can log into some different path itself as soon as you log in as a user account. That's how they have configured it. Is it clear, guys? Still here? Any doubts you have?
Sir, yes. Sir, that /u or /kiran folder, where it inside home directory or under root directory?
Home directory. I'm just saying /home Kiran is a home directory where the Kiran will log in. Rajesh will always, whenever Rajesh logins, he will log in under /home Rajesh, /home Vaibhav. Is it possible, sir, that we change to /home to some other path or some other folder directory or something? Yes, it is possible. It will be done by the administrator.
Okay.
They manage the system, right? So they will do it actually. Clear? There are so many administrative commands and aspects are there, guys. We are not covering as part of this course, but I'm just saying that is very much interesting to understand. If you are learning RHL courses or Red Hat courses, right, you will come across with all those commands, all those concepts very well. So we're not discussing all this. I'm just telling you. Okay. So now, okay, 1 second. Yeah. So cat etc shells will show you that which are all the shells which are currently supported in that particular distribution. So in CentOS, when I'm executing this cat etc shells, it is showing only this one. Now you might say, sir, there are so many other shells are there. What about that? Yes, those shells are not being installed. Like for example, you will say that, sir, there is no corn shell. Okay, corn is one of the shell. But there's no corn shell. No problem, guys, because the corn shell package is not installed in your system. That's the reason. So how to install it in your CentOS? You have to just say sudo yum install corn shell. Enter. And ultimately, it requires 3.1 MB. So this is the only one package which is installing. So there are no dependencies as such. If there would have been any dependencies, it would have been shown even the dependencies also, right? And it is trying to connect with some repo known as a download.cf.centaur.org. Through that repo, it is trying to install this KSH shell. Yes, I'll go with this. I'll say Y and set enter. See, KSH is installed now. Now, if you go to the cat of etc, now you see the entry of KSH, guys. See, now the KSH has come. Earlier it has not come. Now it has come because you have installed the package. Correct? So let me copy this whole stuff from here till at the end. I know we have a video. You can watch this video, but still, somebody want to refer to the document or the notes, they can refer to this note also. Clear? Same thing what happened right here in your case, in your Ubuntu, you don't have that. If you open this file, see, there is no shell. Con shell is not there. But sometime you may need a con shell. So in Ubuntu, before how do you do it? First, you need to run a command sudo apt update. So you are actually updating your apt repositories. That's the reason you have to run this command sudo apt update. So you could see that it is actually updating all the packages. You could see that 68 packages are upgraded, right? These are some of the packages which have been upgraded into this particular repo. After this, I have to run a command sudo apt install, same command, sudo apt install, and then take KSH and enter. So it says that it requires this 3185, almost 3 MB of the additional disk will be used. I'll say yes, and I'll enter. So, okay, don't worry about this one. Okay. Okay. So now it is installed. Now, if you open the file cat etc shells, can you see that now the con shell has been installed? KSH 93. This is the shell con shell. So what you did, guys, you have to run these commands for the Ubuntu distribution. I'm running these commands. So these are all, we will discuss whenever we come to the package manager, right? We'll discuss about this actually. So this is in case of Ubuntu. Okay, clear? Okay, fine, guys. So let me save this. Okay, it's already saved. Okay. Okay, now, so, yeah, right. Now, I want to clarify a few more things, right? Then we'll proceed further. Like, for example, coming back to this older image, actually, where, as I said, right, the file system will be there, actually, right? And where you could see that actually that like the file system is there, and you know that the file system starts with a slash actually, and slash is nothing but your ultimate parent directory, or it's a root file system. It is same thing like a C drive. Now, if you remember, guys, I told you about something about the hard disk actually, right? Now, you know that whenever you are taking any machine, suppose you go and buy a laptop from the market. So right now I'm using my Lenovo laptop. So Lenovo i5 generation, I'm using with 16 GB of RAM memory I'm using. So I will get a hard disk actually within that. I will get a IDEA hard disk or the SATA hard disk. So nowadays SATA hard disks are the more popular hard disks actually, because those are all very much faster working compared to the IDEA hard disk. So earlier we had IDEA hard disk. You know, remember like 20 years back, you used to get IDEA hard disk actually. IDEA hard disk you get. Nowadays you are getting a SATA hard disk. Correct? You'll get a SATA disk. This is not about your SATA hard disk actually. SATA, SATA hard disk. Serial ATA disk. So you might go to the market, or you might purchase a laptop, or you might purchase external drive of 1 terabyte or 2 terabyte, whatever might be, right? So this is nothing but your hard drive actually, a hard disk actually, where it's a storage device, we say, right? It's a storage device. It's a storage device. This is a storage device. Now what happened, as a user, what you have to understand is that actually what exactly is hardware is, it is a SATA hard disk, fine. How many partitions I can create it actually? Suppose you are installing the Windows in your laptop actually. Like you can take the whole drive. You can take the whole 1 terabyte. So assume that this is 1 terabyte actually. Both of disk is 1 terabyte. 1 terabyte. You can take the complete 1 terabyte disk, guys, and you can install Windows on that actually. Right? Take the whole 1 terabyte of hard disk, whole hard disk, you can install the Windows, and you see that there's only one partition which will call the C drive, which will get created. So now, whenever you have installing it, right, you would have seen that while installing Windows or Linux, right, you would have come across with something like, please create a partition, primary partition. It'll ask you whenever you are, whenever you boot up the system, whenever you boot, right, first, it means that whenever you take any CD, nowadays we are not getting any CDs and all, we're everything we're getting through USB bootable, or else the bootable might be there in some external server. You need to connect from yourself to there and start booting up and start installing any new operating system, right? And nowadays, installing an operating system or anything has become very quick actually. Within some 4 or 5 minutes, right, they will install the whole operating system, because they will not install any operating system through the scratch, because they already have an image of an operating system. They'll just try to copy that image and make it bootable and up and running. That's how the system admin will do. So, in the companies and all, no, when they give the handover to the laptop to you, new laptop to you, they will not sit and install it. It is very difficult. It might take around 1 or 2 hours. What they will do, they won't do that. They will already have a Windows OS images there with all pre-settings are already there. They will take that image and they'll try to, like copy paste and make it up actually. That much. Within 5 minutes, they'll make the laptop ready for you and give it. Similarly for Linux also. You already have an image of the Linux image. They will take an image and they'll just try to put it in, copy it and make it up and running. Within 5 minutes, they'll do it actually. That much fast has become nowadays. So it is not like that we will be sitting and always be, installing it. But those days were there where system admin used to install it actually. Sit in a system, install it for until the concept of this image didn't come, right? During that time, still people were installing in the very older method only, like taking a CD, everything one by one taking. Because if you take any RHL 4 RHL 5, right, you used to get some 3 normal simple CDs used to get, or else 1 DVD you can get it. That will take nearly around 1.5 hours to install it actually. So we have to sit and install it, everything done and configure, and finally give the laptop to a person who is an employee. So it will take some time. So what they used to do, like they used to take the whole hard drive, just to format the drive. Format the drive means actually you're creating a fresh new partition. So what the admin will do, he will take the whole 1 terabyte of hard disk, assume that it is a 1 terabyte of hard disk. He will take the whole hard disk and he'll just install a C drive, or he'll just install the whole Windows operating system, this entire hard drive. Oh, it means that whole hard drive. So this C drive, he will consume the whole 1 terabyte disk. Means it will be installed here actually. Or else what he could have did means, usually admin will do that. They will understand that this is a 1 terabyte, 1 terabyte of hard disk is there. He will do one thing. He'll create 2 partitions. He will create like this. He'll create 2 partitions. It means that these are the 2 primary partitions. Now the question comes, first question comes, sir, how many number of maximum partitions I can create any disk, sir? So guys, why I'm saying all these things, this is very important. I'll just explain in 10-15 minutes, but this is very important. So you will say that, sir, you can create a maximum 4 primary partition. 4 primary partitions. Has anyone heard about that, sir? We can create 6 primary partition or 8 or 10. No, you can only create a 4 primary partition. You can take any disk. You can take ID hard disk or SATA hard disk or ATA hard disk or any type of disk actually. You can only create a maximum of 4 primary partition, right? For example, if this is 1 terabyte, you can divide like this. First partition, second partition, third partition, and fourth partition. Like this. First partition, second, third, and fourth. So is there any other than apart from this third, fourth, I can create? No, sir, you cannot create more than 4 prime partition. Fourth partition. Any one, so all these are primary partition, guys. Now, whenever you are installing the Windows operating system, that is not but the C drive requires minimum 1 primary partition to always be there. Either it can take the whole disk as a one partition, primary partition, get installed, or else a system admin has divided this whole disk into 4 primary partition. How will divide it means actually basically guys, he will use some utility to divide it. What is that utility? They'll use something as F disk. Some of you might have come across this F disk utility. Using this F disk utility, yes, correct, Suraj. F disk utility or F disk command, he can create a 4 primary partition. Okay, 4 primary partition. Any one partition, you can make it as a logical or extended partition. In case of a SATA disk, actually, you can create up to 14 logical partition or extended partition. Suppose you take this 4th partition, you can subdivide. Again, you can divide partitions like this. Okay, 1 partition, 2 partition, 3 partition. Like that, how much you can create? You can create up to 14 extended partitions. Extended partition, you can create it. So 14 plus 3 is nothing but 17. So totally in SATA disk, you can create how many guys you can create? You can create up to 17 partitions. Means you have the 4 primary partition, but the 4th primary partition you have make it as an extended partition. You can even create an extended. So any one drive you take, again you slice into some 13 pieces, 14 pieces, right? 14 plus 3 is 17. So totally 17 partition you can create. Same thing in IDEA hard disk case, you can create up to 64 partitions. In IDEA hard disk, you can create 64 partitions. This is the limit. You cannot create more than 64. Similarly, you cannot create more than 17 partition. Yes, 4th is a logical partition, can make as an extended, right? That's what I'm saying. This is a logical partition, but we can extend it. We can even further create many more partitions. Can we create the same thing in C drive? No, you can have to, sorry, can we make it in the same other drive? No. Only 1 partition you can make an extended partition. Other 3 partition remain as a primary partition only. So clear, guys? Now, what happened, right? You have created a partition now. Now, whenever you're installing the Windows, right, you can take any one primary partition, you can take this or this, any one of this you can take, and you can install Windows. Windows will be successfully get installed into the primary partition. But you will say that, sir, in my disk, sir, I already created some logical or extended partition I've created, sir. Can I go and install my Windows here in this logical or extended partition? No, it will never allow at all. Your Windows operating system will always work or it will always get installed whenever there is one primary partition, right? If there is an extended partition or logical or extended partition, you can install it. No, you cannot install it. But vice versa, in case of a Linux, it is the other way. It means that you can install the Linux operating system, that is Ubuntu Linux or Red Hat Linux or any flavor of Linux, right? You can go and install in either in the primary partition, or even you can even install in your extended partition also. Can go and install. Linux will happily, it will get installed. So what now you will do that, guys? You will try to take the Windows, install in your first primary partition, C drive will be installed. You will consider this second partition as something like you'll keep it as a D drive. Okay. For some reason, I will keep it as a D drive. Means I need it actually. So as a user, you keep it a D drive. Now what happened, right? You will say, sir, now we are having one more primary partition, that's a 3rd, and one more extended is there. So now you'll say that, sir, 1 terabyte is there. How you are divided? You can divide into 4 equal partitions, right? 256 GB, 256 GB, 256 GB, and 256 GB. And again, this 250 GB, whatever you have, right? You have again further divided to many partitions, like 14 partitions you have created. This we call an extended partition, right? So 250 GB, again, you sliced into 14 pieces. And you made it as each as a one extended partition, like that, right? Now what happened? You will say, sir, I have given a 3rd partition is there and this extended partition is there. Can I install the Linux over here? Yes, you can install, sir. Now, while installing a Linux, what happened, right? You will say that, okay, sir, this 3rd partition, let it be for the slash partition. Let it be, it means that the whole 250 GB you are allocating to a slash partition. Yes, sir, I am allocating to slash partition itself. Yes, okay, good. Now, guys, in let me take one more this one, or else let me draw it here. Like I will remove this ID. I don't want it because nowadays we are not using ID. Okay. Now, yes. Any doubt still here, guys?
No, sir.
Okay, clear. Okay, good.
Hey,
Now,
hi Rajesh. Sorry to interrupt you.
Hmm.
So far we are discussed around OS level, I guess, right? I'm expecting you to go on Linux command shell scripting. I really
Yes, sir,
want
we'll
to go on automation,
That's what, sir. We'll start it, sir. We are going to start now. After this only, I have just why this is important, because that I want to make you visualize, because when it comes to the commands and all, right, you need to have all this basics knowledge.
Okay.
If you have this basic knowledge, no, then upcoming further classes will become very easy for you to understand.
Okay.
So that's what I said, right? I'm not going very in detail in the administrative aspect. No, my intention is not to get into Linux administration, because if I want to teach you Linux administration and scripting and all, it will take me around 50-60 hours. My intention is not to make you Linux perfect. My intention is to cover the Linux scripting only. But for scripting, you need some basic aspects. So those things only I'm covering, guys. Don't worry. As I said, right, in the first session, right, I might extend few more hours. I will extend in next week also. But don't worry. Just, be patiently listening what I'm saying, so that this will be helpful for you in the upcoming sessions. That's what my intention.
Sounds good. All right.
Hope this is okay, clear, sir. I know some of them feel like, what is this, sir? You're not at all started shell or scripting. Sir, we are going to start now. Don't worry. In another 10-15 minutes, I'm going to start now.
Okay.
Clear? So I'm just setting a platform for you all. That's all. Okay. Now, what happened, right? This is a C partition. This is a third partition, guys. Now what happened, right? Whenever in having a Linux, whenever installing a Linux, see, I know most of you are never involved in installing Linux also. I know that you are never installed, because why you have to worry? Because it's a systematic work. Yes, correct only. But sometimes what happened, right? You need some basics knowledge also on that. Like for example, in Linux, you will have something known as a slash partition. Slash is the ultimate parent partition. You'll be there. Apart from the slash partition, you can even separately create a slash home partition, slash var partition, slash user partition, and also swap partition or swap partition or swap areas. Apart from this, any other thing? No, sir. Can you create a separate partition for the etc directory? No, you can't create. Can you create a separate partition for the slash lib directory? No, you can't create. Can you create a separate partition for the slash temp directory? No, you cannot create. You cannot create any partition for these things. You can only create a partition for the slash home, slash var, slash user. Guys, you can mute it, some of you. Okay. Now, here what happened that this is the ultimate partitions which you can create. But you might say, sir, I don't want a slash home, var, user and all. I don't want it. Can I have only slash? Yes, sir. It's same thing like a C drive. Only C drive is there. You can same thing like a slash partition. Now here what happened, based on your disk size, you can even allocate you can given slash 250 GB for the slash partition. Slash home, you can give it something like 100 GB. Slash var, you can give it as some 50 GB. Okay. Okay, you can give, and the slash var partitions, slash user partition, you can give 150 GB or 200 GB. It depends upon you. And the swap area is always a double the RAM size. If your RAM is 16 GB, swap will be 22 GB. So always swap will be, for some reason, it will be double the RAM size, 2 into RAM size. Here, guys, these are the separate partitions which you will be creating separately whenever you're installing Linux. So you can create this separate partition. Now the question comes to you, some of you might answer me, like, why we are having this separate partition? Slash home, slash var, slash user. Can you tell me why we are having this? Or why do we tend to create this separate partition in Linux actually? I know you guys, some of you might not be expert in anything, but I'm just asking in a, just a common, it's like I'm asking you like not as a too much technical, like something you can give a kind of a layman answer for me. Okay, why we are creating a separate partition?
These folders are mostly using in the Linux.
Correct. Okay. But you will say that, sir, I can have this whole everything I can have in only slash partition only. Okay. In the slash only home where USR, everything will come. But you can even create a separate partitions altogether. Why we do? Because that, for example, your system get corrupted, the whole file system will get corrupted. Assume that. Still, what happens? Slash home, slash var, slash var is that you can recover all your data back. Right? These are the separate partitions. So if you take this entire 1 TB of a hard drive, you can create a 4 prime partition. You can assign this slash partition to be installed in your first partition, slash home to be installed in your second partition, slash var to be installed in the third partition, slash user installed in the fourth partition. You can do that while installing it. So assume that in a single server, you're only installing Linux. You don't have any Windows and all, right? You can create this partitions and you can allocate a separate disk for this. Create, because if this suppose first partition will go off, it means the first partition is a slash. The slash partition will go off means what you will do? You cannot even boot up the system also because the whole slash partition is gone. But assume that you have kept a lot of important data in slash home Vaibhav or slash home Kiran. You need to recover back all those data. Yeah, you can go to rescue mode, mount the second disk and try to recover all that. Same thing, you can go and mount all important logs or the system logs and all. You want that important logs. You can mount this third partition, go to the rescue mode, Linux rescue mode, and go and try to, mount this slash var partition and try to recover the data. That's the reason, guys, we try to create a separate partitions for the other file system folders. If there's only one disk, no, we can't do, sir. Everything is corrupted, means corrupted. That's all. So there are some third-party softwares are there. Using that also, you can try to recover the data, but still assume that the whole disks has been corrupted. The disks has been corrupted. The whole sectors has been corrupted. You cannot do it, means then we cannot do it, sir. They will at most try to recover almost all the data, but sometime what happened, your sometime what happened, the whole there are bad sectors are there where you cannot recover at any chance. Means then there is no case, sir. You cannot do it. But that's the reason what happened that always company will take a regular backups, right? So whenever you're having a servers, right, always they will take in a tape drive or there will be some external storage like tape drives where they'll be completely taking up all the backups, and that is taken care by the recovery and the backup teams. Actually, there's a separate team will be there where they'll be keep syncing the data. Actually, it means they'll be taking a regular periodic, yes, LUNs are there, so many other those concepts are there. Yes. Clear, guys? There is something like a mirroring is also there. There's something like a RAID levels are there where you can stripping of the data are there. We'll say that whenever you write a data into one disk, at the same instance, that same data will be written in the other disk also. That is nothing but mirroring, we say. So these are all the very highly concepts which comes under the Linux administration. That's what I said that I'm not covering all those things. But these are the very, very fundamental things which we have to know it actually. Okay. Now, why I told all these things, because that it is because we have to something understand about the partition. We have to something understand about like how Linux, what are the different partitions you have in Linux. Slash home is a partition, slash var, slash user. That's what I said. This partition are also very much important. Clear? So guys, any doubts you have till here? And we will get into now shell.
Hello.
Yes, good.
So slash is the same as the C drive in like Windows. Just
correct.
Okay,
yes.
okay.
Same thing. Don't
And-
consider that sir, D drive is something like slash home, slash var is something. No. You have
Okay.
you have a D drive, E drive, F drive, and all. These are the free part. These are the free partitions where you can store any kind of data, whatever you need. Right.
Okay.
Suppose in your system you have D drive, E drive, F drive. Does it make any sense? No, it's a free drive only. You can go and even you can install a new operating system in a D drive. You can install a new operating system in E drive also. But that is a free disk drive where a user can do anything. But whereas a slash home, slash var, slash user, these are all the partitions which are relevant to your Linux partition only. Means there has to be a slash home, there has to be a slash var, there has to be a slash user. All this has to be there in your Linux. Whereas in Windows, you can only have a C drive. That's all. No other thing. You don't need a D drive, E drive, drive. That's all external drive which you need at the later point of time whenever you want to store any other data. Usually what happens, user don't want to store all the data in the C drive only, right? You know, like suppose you in your home, you have a laptop, right? You have created two partitions, C drive and D drive. In the D drive, you'll keep all your videos, files, even in all your games, you'll install it in a D drive. You can go and install it, or you can keep all your external files, everything, movies, everything in a D drive, right? You don't keep it in C drive because you see that, okay, tomorrow the C drive is corrupted, of the operating system is lost, right? You can still recover all the data what is in the D drive, right? Because you can mount it. You can go to the rescue mode of your Windows, right? And you can go and you can mount it. Have you guys ever tried about all those things, going to the rescue mode and trying to mount that partition, recover all the data? Have you ever, any one of you have did that, or you were involved in doing that? Very early, I'm saying, not now. No, right? So I was involved in doing all those things. Doing that, even in my local system only, I was doing that actually. In my local laptop only, I was going to the rescue mode, go and understand what is that partition, where all the files are there, mount it and trying to take a recovery of data, take the backup of the data. Okay, fine. Now, coming back here, guys, yeah.
Why that swap area is double the RAM? Is there any particular reason?
Yes, sir. Actually, what happened, right? Whenever you are creating a processes, a lot of processes are getting created in Linux. Actually, Linux uses processes. Like we have a process, and always process need a virtual memory, sir. Always process need a virtual memory. Whenever any process is getting created in Linux, it needs a lot of virtual memory, sir. A lot of virtual memory is needed actually. Around 4 GB of virtual memory is needed for each and every process. See, I'm telling in a very high level, guys. See. See, a 32-bit process, you will only be able to access a 4 GB of virtual memory regardless of the OS. This is due to the process only being able to map 32-bit of memory. So why I'm saying this, because guys, whenever any Linux process is getting created, it needs a lot of virtual memory. That virtual memory, either it comes from the RAM or either it can come from the swap. So what is the swap? Swap is all about the virtual memory. So suppose if you have a RAM of 16 GB, this is my RAM. This is my RAM memory. This is 16 GB. And this will be a swap area. It will be an extended of RAM, we will say. Like this will be a swap area, like this. So swap area will be attached to the RAM area. It will be attached, swap area. This is a swap. So if a RAM is nothing but your 16 GB, swap should always be double the RAM size, 32 GB. Now, whenever any process is getting created in Linux, each and every process, we need to get 4 GB of virtual memory space. 4 GB of virtual memory is needed. That 4 GB will be allocated from your swap area only to this process. That's the reason what happened, right? You will always see the swap area is always a double the RAM size. For some historical reason, they have kept always a double. Is it clear, sir? Till here?
Yes.
Yes. Good. It's a good question. Whatever you ask, that can we have double, more than double? Yeah, you can keep it, sir. Actually, no problem. We can keep it actually. As you can keep it. More and more size you keep it. Sometimes what happened in many companies, or what happened, they'll give a very big swap area. But sometimes what happened, the swap area itself will be filled up. Means that there's no free memory in the swap area itself. So, but what happened, you can create one swap file actually. You can create a swap file, attach that swap file to an existing swap area. That also as an exercise we'll see in the upcoming session. That is only very interesting thing. Means you can create a swap file itself. Yes, sir.
Yeah. Whether I was knowing like swap area it will get from the hard disk area, right?
Yes, this is a hard disk only. This is an extended of your hard disk. This is a hard disk only. From hard disk only, you're getting the swap area. Yes.
Okay. I missed here. Okay.
Yes. Here, what happened? The swap area, it is coming from hard drive only or hard disk only, and the swap area will be having a swap file system.
Okay.
We're having a swap file system. This is a separate file system where it will be there. And when this will get attached to RAM area, this will get attached to RAM memory during boot up time. During boot up time only, it will get attached to the RAM area. How to check that, guys? What is the command to check that? You know very well that there's a command known as a free command. p-m command, yes,
Yes.
this will show you that my RAM memory in this system, I'm saying that it is 1 GB of RAM memory. How much is used? 227 MB is used. Free is 129. And what are the buffered 588? Is there any swap area? No, there is no swap area at all. So because this is the server which we got from our cloud environment, right? That is on AWS, they won't give the swap area for you. Right. Similarly, here also, go to the CentOS, execute the free-m command. You could see that they will give you what is the memory area versus swap area. This is one of the intro questions they'll ask you. Clear? Okay, guys. Chalo. Now.
Thanks.
Yeah. Come back to here. Sorry, guys. We tangentially went somewhere else, but that was important. So now, what happened, right? We have so many shells are there. The Linux supports almost all the shells. So now, what are the different types of shells we have? This is very important. You know the types of shells. Now from here our journey starts about the shell or shell scripting and all. From here we are going to discuss. Now we have a lot of shells. When the Unix came into the picture, the first shell which came was a bound shell. Bound shell. This was, in short, we called as a SH shell. In short, we call it a shell. And this was designed by the person named Steve Bourne, actually. Hence the name bound shell was kept, actually. This was a shell which was first integrated with our Unix operating system, right? And this shell, bound shell, has a lot of features, actually. It has a lot of features, right? And people were happily working on this shell, actually. This was supporting many features. Later, after some point of time, guys, what happened, right? There was a new shell which came as a C shell. C shell, we call it SH shell, CHS shell. It was developed by the person by the name Bill Joy, right? So there are few disadvantages which were there in the bound shell, but it was all those disadvantages were fixed in the C shell. And whenever you write any script under the C shell, what are the syntax you follow in the C language program, right? The same syntax are followed in the C shell also. So guys, there are so many shells are there. Each and every shell, the working is different. Even the syntax are different, right? Even when you're writing any script, right, you need to follow the syntax pertaining to that shell, actually. You need to follow the syntax pertaining to that shell. Yes. Yes. Con shell. Yeah. Born again shell. Yes. Correct. Right. So scripts, the syntax for the C shell is same as the syntax followed in C program. More or less, some of the syntax, whatever is there, right? After the C shell, you come with something as a con shell. And we call it as a short SH shell, actually. Now, this con shell, right, it was developed by the person by the name David Korn, actually. And most of the other operating system, like your HPUX or IBM X, right? IBM X, they started using this con shell, actually. Con shell has a lot of features, actually. But many other features were missing. Like, for example, your command and editing was missing, actually. And even your history command was also missing in this con shell. But during those time, when the HPUX or IBM X came, right, people started using heavily the con shell. A lot of scripts people started writing in the con shell, actually, right? And it has a lot of other features also. KORN, con shell, actually, right? Some people even call it a PDK shell. PDK shell, public domain con shell. We call it a PDK shell. And afterwards, what happened, right? You came across with the bash shell, actually. So bash shell, okay, was designed by your Free Software Foundation itself. Okay, and it has a lot of features. Like basically, what happened, right? Whenever you are working on the con shell or the C shell, suppose you're working on the con shell or the C shell, whatever the script you have written in the con shell or the C shell, can it be executed by the bash shell? Yes, it can be executed by the bash shell also. Because whatever the syntax, what is there in the con shell, C shell, it is understood by the bash shell also. That's the reason con shell, bash shell is not, but it is a complete implementation of the C shell and the con shell. So what are the features within the C shell or what are the features within the corn shell? Both together we call it as a bash shell. But again, bash we call it as a born again shell because it's a complete re-implementation of the bound shell itself. So whatever you have a traditional shell, right, which was used in Unix operating systems, they took the same shell, bound shell, but they added all the syntax of the features, whatever there in the constant C shell, and they came with this bash shell. So bash shell is the most famous shell which we use. Even till today, we are using the bash shell. No other shell has been replaced till now, right? So you need to learn the bash shell scripting actually. Bash shell scripting. Clear, guys? Now, whenever you're writing any bash shell, right, you'll always give a .sh as an extension for the bash shell. Always, whenever. Or whenever you write any bound shell, you always give a .sh. So .sh is number, it is an extension of the bash. It means that whenever a user sees the .sh, he will understand, oh, it is a shelf, it is a script file. He will understand it's a script file. Similarly, whenever you see .c file, what you will understand, oh, it's a C program, sir. You will understand, right? Whenever you see any, wherever you see any file which is having a .pl, you call it as a Perl script actually. Similarly, with the .py, it's a Python script. Whereas a .rb, oh, it's a Ruby script. So file extensions matter a lot because even your system or the operating system understands the type of file with an extension also. Right? With the extension also, it understands it. So you have to always give the extension also. But still, what happens? Some people say that no, extended is not really required because without even extend also, what happened? Your system or the Linux system can understand what type of file. Based on that, it does an operation. Yes, that is correct only to some extent, but always it is better to always give an extension, guys. Always. Okay. So now the question comes, sir, actually then what is nothing but the difference between something like a high-level programs versus with the scripting actually. So guys, actually what happened, the whole programming stuff, actually, if you take the whole programming, they have been divided into the two types. One is a high-level programming, okay, and some of them are scripted level programming or scripted languages, right? High-level programming, you know very well that you have a lot of language, like you have a C, C++, you have a Java, right? You have a Node.js, we have a Go language, right? There are many languages are there, right? Through which actually you try to write the program code actually, right? So whenever you write any application, right? For example, whenever you are writing any web application or whenever you're writing a database application, right? So you write any application, you tend to go with any one of the high-level language programs actually. You cannot do the programming everything in the scripting. It is very difficult. You cannot do that. You cannot achieve the business logic by writing an application using the scripting. It's not. It is very difficult actually. You cannot do it actually. But where you have to always go with the high-level programming, like C, C++, Node.js, .NET, Go language. There are many languages out there, right? You can go with any one of the language to code your application. And whatever the business logic you need to write, you can go ahead with writing this with a high-level level. So now all this language, guys, C, C++, or Java and all, these are all compiled language, compiled program language, compiled program languages. Right? It means that what are the program or whatever the program which you have written, you need to convert into the machine executable format, or you can call it as a assembly level format, so that the program start getting executed their system. Right? So whenever you want to convert any high-level program, you need to convert. Like suppose I'm writing in a C program, I want to convert the C program into the executable program. Then I need a compiler. Do you agree with me, guys? With this, do you agree with me? Right?
Yes.
For example, I'm writing any DOS program, right? Or else I'm writing any, I'll take a C only. Suppose if I take a C, I want to write a C program. I want to convert the C program into the any kind of executable format, that is A.out format. I want to convert. I need a GCC compiler. Similarly, for the C++, I need a CPP compiler like that, right? For example, similarly, for the example, like whenever you are writing any .NET or any .NET based application, right? You need something like a Borland compiler. So you will come across with a lot of compiler guys actually, right? For example, whenever you written a Java, you know that actually I can use even Ant build tool or Maven build tool. Those are compilers only actually. Those are compilers. So what the compiler will do? Compiler will convert the high level language program into the assembly level, or we can call it as a machine understandable language. Machine understandable language. Machine language. So this is what it is. I'm not really getting into much into what exactly the compiler is all about, how it does everything. We need not to know all those things, but I'm just telling you that it converts this program, the high level language program, because your system or your operating system cannot understand the language as this. Whenever if you've written any program with this language, right, you cannot take a directly program and run it. It'll never run like that. You have to always convert it actually. Or C always it uses a .out program, right? Similarly, your Java will always have a .java as an extension. So after you compile it, you'll get a .java as an extension. This will be in a COP format. Actually, we say that. You'll get it. Similarly, like Node.js, Go, and all, it will get converted into some understandable executable format where the system can execute actually. So now, what happened, right? When the compiler compiles a program, it converts the whole program, a C program or C++, whatever you have written, right, into the machine understandable language program or into assembly level language program, we say. And once you get the assembly level language program or the format, right, then your system can execute it. Who will execute it? Again, your kernel only will execute it, actually. Like that. So, like that one. Now, what happened, right? You have chosen this high level language program to write or to code an application. Okay, this is one type. This is one set of programming language which we use. Now, whereas a scripting level language. What is a scripting level language? Scripting languages. You have many of the scripting language programming scripting level programmings are there. Like for example, today we are learning the bash shell scripting, right? Or the scripting, right? So we have the scripting actually. Scripting. Right, for example, you have a bash shell or the conf shell, whatever. You can use the bash shell to write any script, actually. So this bash shell, whatever the script we write, right, we call it as a interpreted languages. Interpreted languages. Or interpreted programs, we say. Now, guys, why we use this scripting actually? Because, for example, whenever you're working on a day-to-day task, right, you go to the office, log into some server, you will tend to run some commands every day. Like, for example, you will tend to run some commands. You'll try to ping to some machines. You'll use a ping command to ping to some machines. Okay. You need to run some routine jobs. Actually, you need to take some backup programs. So what you'll do, you'll go to some folders, go and run a copy command to take a backup, right? You need to monitor some system. You need to monitor your CPU usage or your memory usage. You will tend to run some commands. Like, for example, you run a top command. We run a vmstat command. Stop command, like that. You run some commands to manage or to check what is the CPU or the memory which is utilized. So what you're doing as a user, you go to the office, you tend to do multiple tasks on a day-to-day activity. It could be a routine task, and most of the routine tasks will be a manual. It means that you will try to go and execute it. You will try to go and execute some particular command related to that, whatever you're looking for. Right. So when you're executing this command, maybe sometime what happened, you might be serially executing these commands one after the other. Okay, let me check first the disk. What is the disk is there? What is the disk usage there? Okay, let me check whether which server is up and running by using a ping command. You do it. Okay, let me take a backup of it. Oh, yesterday somebody returned a file. I need to take a backup. So you will tend to do many things, guys. Actually, you will tend to do many things. So what a user will do? Yes, line by line execution. Correct. We will come across with that. Yes. Now what happened, right? When you execute many of the commands, so as a routine or as a day-to-day task, you will be tend to execute all the commands manually. Now, as a system admin, what you will do that? As a system admin, what you will do that? You will choose the bash shell actually and write a script and run that script daily. It means that you need not to now do it everything manually. You have to just run the script. So by running a script, you are automating your task of executing everything. It means that whatever the 10 or 12 or 15 commands, whatever you're executing every day when you log into the office, right? Now you have written a script for that and you're running a script. Now what happened? That script will take care of running everything. So now you have automated the task actually. Yes, sir. We'll come across that. Scripting is making an automation, right? It's an automation only. Whatever the manual we are doing, now we are automating. We are not doing anything manually now. We are just running a script actually. Right? Now, so now what happened, right? You are running everything manually. Now what happened? The time has come now where you need to actually start seriously writing a script. It means that all this is you're doing something manually. Now you have written some script for achieving manually. Now sometime what happened? After some time what happened, right? You will get some task actually. So what you'll get a task, guys? You'll say that, okay, guys, there are some 1,000 servers are there in your data center. 1,000 servers are there. And admin will be told that, hey, go to all the 1,000 servers, man, and upgrade the packages. Upgrade the package or take the backup of all the logs. Take the backup of all the system logs. Or he might be told that, hey, go out to all the 1,000 servers, go and install some package or softwares. Guys, do you think that the administration or whoever is doing, right, he will log in each and every one server, go and upgrade the package, take the backup of the legs, install some package and come out, again log into the second server, again log into the third server. Do you think that he can do everything like that? It's very difficult, right? If you want to do all these things, it will take months together to complete the task. Or it might take weeks to complete the task. It is highly impossible, and making it manual, doing it manually is it is a nightmare for the admin, right? It's not one person. You need to have some 10 engineers or 10 admins who need to complete all this task. So hence what happened, that admin will write a script for that and he will run that script. Now you will say that, sir, every day, sir, I don't want to run. I want to log into the system every day, sir. Run midnight at 12 o'clock, sir, every day, sir. Can't I make it to run so that it run automatically? Yes, sir. Take that script, set it a cron job for that. Set a cron job, run every day. Every day. Every day means not every day. It means that every day means from Monday to Friday, I'm saying. Business working hour. Every Monday to Friday. From Monday to Friday. Every day, midnight. At 12 a.m. IST, night time, please run this script, we'll say. It means that you have set a cron job for that. So this is what an automation which will be done by a system admin, guys. Earlier, all this automation even was taken care by the developer only. Developer used to write a script, but now those days are gone. Developer have stopped writing the scripts and all because he will not be involved in everywhere. He will be only concentrating on writing an application or maintaining his application. Right? Now the admin job has come into the picture where he will start doing it. So slowly as things get progressed, there are many other automation tasks are there, which you can achieve through writing a script actually. So after the batch, right, guys, there was a requirement in the organization that they have to do many other operations apart from doing a normal operations. So to doing that, you cannot achieve everything to the bash shell. Bash shell has a limitation. You cannot do any kind of a high mathematical computation using the bash shell. It is not possible, right? Because bash shell doesn't support, there is no concept of the models or libraries. There are no concept of model or libraries. By using the models or libraries, no, you can achieve everything in the bash. No, bash is only used for some daily routine job which you will execute as a part of executing the commands, right? Whatever you do, right? That thing you can automate through writing a bash shell script. Not everything. You cannot code, you cannot do everything by using a shell script. Like for example, as I said earlier, like you cannot do any kind of a high mathematical computation. You cannot do it, guys. Mathematical computation, you cannot do to the shell script. You cannot do, right? You cannot do that. What are the other things? Whenever it comes to security, you are implementing some security services or security related stuff you want to do. You cannot do through the bash shell. It is not possible. Same thing you can do either through the Perl or either through the Python or even to the Ruby. You can achieve all these things. Suppose you are writing any code, high mathematical computation you are writing, you can write it, you can implement in the Perl. Perl supports, because Perl has its own set of modules or libraries. Using that, you can actually automate everything. Similar Python, similar Ruby. Correct? So now what happened, right? So why we are using bash shell scripting? Bash shell scripting is nothing but it is used for your daily routine task. Whatever you are executing in a system, by sitting in a system, by executing some commands, right? Now you can start writing a script for that. So what you need to understand, the main important thing that as a whenever I want to write a script, what all I needed? What all I need? First thing is that the commands, guys. You should know all the system commands or nothing but the Linux commands. And also you should understand what is an output of that command. Output means how the output look like. That is what we have to know. Oh, first important that, okay, I need to know the command. I need to know the commands. Also I need to know the command options. What are the command options are there? And after that, after we execute that command, what are the output you get? No, that output also I should understand. Oh, in that particular format, I'm getting output. So once you understand all these things, now you know that, okay, I know that how this command works. And the second important thing is nothing but whenever you are writing any script, right, you need to understand that script syntax. You need to understand. This is very important. Script syntaxes. Yes, we need to learn all the script syntaxes and your constructs, programming constructs also you need to understand. And the third important is that you need to understand about what is a shell features, okay? What are variables, right? And how the shell works. If you know all these things, guys, if you know these things, then you can become a very good script writer. Whatever I want to write a script, whenever I want to write a script, what all I needed, and how to become a good script writer. Clear, guys? So this is all, guys, we need to learn actually. Is it clear? It makes sense? So now, so what happened, right? Now, whatever you're writing in a C program, so C program or the C language, it is a compiled language, as we discussed. It's a compiled program language. Whereas a bash shell or the shell becomes an interpreted language. Yeah. Now the question comes, sometime a question comes, sir, what is the difference actually? Then in interview, they might ask you, what is the difference between the compiled program versus interpreted? Now, to make you understand, actually, right, let me write a small C program. Okay, even though it is not really required for us to understand. I'm just telling you, when you write a C program and when you compile the C program, what kind of output you are going to get, and how to compare with that with the script. Actually, you will understand now. So suppose I will go with your CentOS or you will go with the Ubuntu. I'll go with the Ubuntu. Whenever I write any C program, I will try to give a .c as an extension. So I'll just say, right now, guys, I have not come to the VI editor. I'll soon come, but I'm just telling you that whenever I want to write any file or whenever I want to, create any file or write some text inside a file, I use a VI editor. VI editor, we call it a Vim editor. So I say VI. Suppose assume that I'm writing my first script actually. Like I can write like a hello world program also. I'll just say hello.c program. .c is an extension I have to give and enter. I got it to insert mode, and don't worry about all these things. Hash include. You might have seen these things in your engineering days. You might have seen some header files been included like this. Correct? You might have seen this actually like this. Printf, hello world, something. You might have seen this. Like that you can, I could have even written a Java program also, but that's fine. So I've written a simple C program we have written, and I'll say this file. So shift W kilometer is saving and quitting from the file. We will come across with that later. Don't worry. When I do an ls, you could see that I have a hello.c program. If I do a file of hello.c, you could see that it's a ASCII C source file. That's what it is saying you. Now you will say that, sir, I want to compile this program and create an executable file, sir. So I'll say that, sir, please use the GCC command. So I'll just use the GCC command, GCC hello.c program. Enter. So GCC command not found. He is saying that sudo apt install GCC. Okay, let me install the sudo apt install GCC -y. I don't have a GCC compiler, guys. I'm installing it. Okay. Just okay. apt service. Okay. It'll get installed. Okay, guys. It is installed. Now, after installing, you could see that I have a hello.c. I'll just say GCC hello.c program. So see, guys, there is a file by name a.out has been created. So this is a assembler output, or this is a assembly file, or this is an executable file which you got it actually. Now, if I execute, if I want to run a program, I'll just say /a.out. Enter. You have got the thing hello world. Whatever you had in a print statement, right there in a print statement, right? The same string has been printed here into the standard output. So it means that this C level, whatever the C program, whatever written, right? To convert or to make it to run, you need an executable file. So how you can get an executable file? Through the GCC command or through the GCC compiler. So the compiler, what the compiler has did, guys? Compiler has whole program, this code of program, whatever you have hello.c, whatever you have this hello.c, no? This is nothing but it is written C language. So what the compiler has did? The compiler has took this program. This is a GCC compiler. So what the compiler has did, it took this C program, whatever it had, okay, this whole program, whatever it there, no, it took the whole program as one, and it converted into the machine understandable language or into the assembly level language actually. So it has converted and it has given you the a.out format. So a.out is a executable format. It has given a a.out program. So what I have to say that, sir, what exactly the compiler will do? The compiler will compile any high-level language program into machine understandable language program. By taking the whole code, by taking the whole file, everything together, take it, understand the syntax of the whole program. Okay, understands the syntax and understand the lexical analyzing, applying lexical analyzing, everything it does the compiler, and finally it converts into the assembly level language program or into the machine understandable language program. And you will get a a.out file actually. And how you execute it, guys? You will execute it by just taking ./a.out like this. You will just say, correct? So the program will start running. As soon as you do it, program start running. Now you will say that, sir, I always, whenever the GCC converts it, does it converts always to the a.out? Yes, sir, it will convert always to a.out. With the same name, it will convert. Now you will say that, sir, I don't want the same name, sir. I want with some other name. Now here what happened, you are having a.out. I don't want with this name, sir. I want with some other name. Then no problem, sir. GCC -o output file with what name you want to give, with the name something like a Raj with that name, and what is the file name? Oh, hello.c, and enter. Now you could see that it has created an executor with this name Raj. Now I can run a program /Raj. It will run it. Clear? So till here, are you clear, sir? Any doubts you are having?
No, sir.
Okay. Now, so fine. Now what you're doing here, you're trying to write a program and compile it. Fine. It's a compiled language, GCC, the C language or C++ or Java. These are all compiled language. It means that it will compile the high-level language program into the machine understandable or the low language or the lower language, we say, where the machine can understand and where the system can work on that. Right? Now, so come back to here. Yeah, that's how it is. Now, whereas an interpreted language, like your bash shell, it's an interpreted language. So what happened, right? The interpreted, now you have a bash shell here. Now you have a shell now. We have a bash shell. Now what bash shell will do always? Now, for example, suppose bash shell will get the input of ls command. It will get an input of ls command. ls command or date command or who command. You'll get input of any one of the command, or even when you're executing a.out also, right? It is getting a input as a command only. It'll take an input of the command. Okay. Now what the bash will do? Bash will try to understand, because this ls command, it is not a script. It is a binary compiled it is already pre-binary compiled program. All these commands are binary compiled already. It has been pre-compiled. You have to say that all commands in Linux is already pre-compiled programs. Please understand this, guys. Actually, it's very important. All these commands are pre-compiled. It means that ls command, dot command and all, it's not like you need to compile the program. No, it's already been pre-compiled and kept actually. What the bash will do that, it interprets that command. It understands that command, where that command is placed first. I need to load that command and execute it. That's what the bash will do, that it will interpret that and it will try to execute it. It means that it will try to execute the command. So what the shell will do? Shell will try to execute each and every command. It will interpret it. It will interpret the command. Interpret the command. First, it will try to search that command. We already discussed this. Search the command. That command means in which path the command is there. The command is placed, and then it will load that command and execute it. This is what the shell will do. So that's what we say it as a shell, as an interpreter. It acts like an interpreter, or we call it the interpreted. We call it the interpreted. So now here what happened, right? Here when it comes to the compiler will compile the whole program, guys. The whole C program, whatever C++ or Java, it will take the whole line, each and every line, it will take the whole logic, it will take the program, and it will try to compile, and it will try to compile the program into the machine understandable. Whereas shell, it is going to execute. The shell is going to execute, or the shell is going to execute already the pre-compiled program. Means it need not to compile anything. Your shell never compiles it. There's nothing like a shell will compile it. No. Yes, all the commands are written in C language only. Your ls command, date command, pw command, all the commands, whatever we are executing, already they are pre-compiled. Means they are already there. They are written in C only, guys. They have already been compiled and kept in some location. So shell is going to load that command and run it. That's all shell will do. So now what is the difference? You have to say that, sir, whenever you are having any C language or the C++ or Java, any program, high-level language program, it compiles it. The compiler duty is to compile the program and compile into some kind of an output where it can execute. Whereas a shell, it is an interpreter. We say it is going to execute the already pre-compiled programs. Now what happened as a system admin or as a system admin or as a any other engineer like your DevOps engineer or any other engineer, right? Now you will tend to write a script actually. You'll tend to write a script. So now what happened, right? You'll tend to write a script. This is a script actually. So you'll use some logic, you'll use some program construct to write a script. You will write some 4 lines or 10 lines of script like that you will write. So assume that this is a script you have written. Now this is a script, guys. This is your bash shell script you have written. Right? This is a bash shell. Now here what happened, right? You will be writing a script. So you will be tending to write some lines. Suppose assume that you have written some 4 lines of the script actually. Right? 4 lines of script you have written actually. Now what happened, right? What you will do that now you'll take that script, you give the input of this script to this bash shell now. Now what bash shell will do, it will take the script, it will take the whole script and it will try to execute the script line by line from the top actually. So it will execute the line number 1. Okay, fine. Execute the line number 2. If there is any error in the line number 3, the shell will execute the third command, but it will say that there is an error. Now shell will bifurcate and go with the 4th line. It means that always shell will not exit out from the shell, from the executing the script actually. If there is any error in that script, if there's an error in the script, what shell will do? Shell will try to check it out. Okay, there's an error. It will try to throw an error. What is that third line is all about, and it will try to go to the 4th line, 5th line, 6th line like that. If the 10 lines are there, all the 10 lines will try to execute it by your shell actually. So what the shell is doing? Shell is interpreting this script line by line, we say. It is interpreting the script and it is executing the script. It is not compiling the whole script. No, shell will never do compiling. Unless and until you might ask, sir, whether the Python will do the compiling, whether the Perl do the compiler. Perl and Python also what it will do, guys, it will compile the program, okay, and it will run it actually. It internet does the compile and run it. It does both the jobs. So even the Python and Perl is also called the scripting level language only, but internally how Python and Perl works means it will compile and it will run it actually. Here what happened, right? Your shell will not compile it because shell is already using the pre-compiled programs. Already it's been compiled. So it will try to just execute the pre-compiled programs line by line. So that's the reason what happened, right? Bash is called as interpreter because it interprets the script line by line. It executes the script line by line. If there is any error in the 4th line or 5th line, 6th line, it will try to execute that line and it say that that command not found, or it might throw an error, and then it proceed further for execution the next line actually. Line by line it will execute. This is the difference you have to say in the interview. What is a compiler program and what is an interpreted program? You have to tell like that. Is it clear, guys? Do you have any doubts here in this? This is very important.
No,
Solomon, sir, any doubts you have? Kiran?
No, sir, clear.
No, sir.
Okay. Okay, good. Now, same thing. Now, for example, you will say, sir, I want to write a script, sir, now. I want to write a script. Okay, good. I want to write my first script, sir. I want to write. I want to run the script. How to write a first script? As I said earlier, right? Whenever you write any script, .sh extension should be given for every script. So I'll go to my Ubuntu. Okay. I'll go to my Ubuntu, sir, or you can even go to the CentOS. So I'll go to CentOS here. I will write what script actually. I'll just say vi command, vi. What is it actually? My first script.sh. I'll give this name actually. FIRST, first script.sh. Okay, whatever. First script.sh, whatever. I can give any name. I'm just giving. I'll open this file. Always the first line of the script should be always /bang, #bang /bin/bash. This is always my first line of the script actually. Then I'll use something like a echo something. Enter the value. Read some variable name var, and then I'll just say echo $var. So I'm just writing some 4 lines of script, guys. This is my 4 lines of script I'm writing. And I will save the script. Don't worry now. Okay. Don't worry now. Don't worry now about this one. Try to just see what I've written. Okay. Don't worry about what is this. where what is this echo, what is this read and all. Don't worry now. Just understand, okay, this is some script I have written. And always the first line of the script should always start with the #/bin/bash. So let me copy this thing, guys, and let me keep it here in my notepad. So we understood about the difference between compiled and interpreted. So, and then like the first script actually. Always give .sh extension while writing any script. This script guys have written. Yes, #bang means shebang. Yes, right. Correct, Suraj. Now, whenever you are writing any script, guys, always you need to write this first line as a shebang or #/bin/bash. So the shebang, we call it as a magic character. Shebang is called as a magic character. We even call it as a magic character. So the shebang will tell the operating system or the kernel to execute the script under the bash shell. Because I'm using #/bin/bash, please guys don't do one thing. Sorry, one more thing. Don't give any space here like that. It should be without space. It should be continuous. #/bin/bash. This #bang will tell the operating system or the kernel to execute the below script under the bash shell. Suppose tomorrow you're writing any script in the Python shell, first line of the Python script will be #bang/usr bin Python. Like this. This is the interpreter. This is the path where your interpreter is placed. Similarly, this is the path where your bash interpreter is placed. /bin/bash. So #bang will tell the operating system or the kernel to execute the script under the bash shell. Similarly, this #bang will tell the operating system or the kernel to execute your script under the Python shell. Is it clear, guys? Similarly, you are writing any script on the Ruby /usr bin Ruby /#bang/bin/usr bin Perl. Like this, you will give as a first line in whenever you write any script. Whenever you write any Perl script, you will always give this line as a first line. When you write any Python Ruby script, you'll write this. Similarly, like when you're writing a Python, you'll give like this. This is very much mandatory. Is it clear? So #bang is a shebang. It's a magic character. It will tell the operating system or the kernel to execute that script under that specific shell. So whenever you want to run any specific shell under the Ruby, you have to say Ruby. Whenever you say as a Perl, you have to say Perl, and Python, you have to say Python. After this, so this is the 4 line of code which we have written. Good. Now I want to run the program, or I want to execute the script. How to execute the script, guys? There are 3 methods are there. There are 3 methods, simple methods. The first method is sh space specify the script name. In our case, the script name is first.sh, right? This is the first method. Okay. Or even you can either say sh specify the script name, or else you can even call, or you can even directly call the bash shell, bash space specify the script name. This is the first method. The second method is /first script.sh. Whenever you're using a second method, always you need to have a what? You need to have a execute permission. Means you have to have execute permission. First, you have to say chmod +x and specify the script name like this. Once you have an execute permission, then only you can execute with this second method, /. Suppose you don't have an execute permission when you're running a /first script.sh, it says that permission denied. You don't have an execute permission. Like that, it will throw an error. And the third method is nothing but the source space specify the script name. Or you can say dot space specify the script name. Source or dot is one of the same. Is it clear, guys? Source or dot is one and the same. Now, let us see how to execute the script. Okay, I'll go back to my CentOS machine where I have the script first script.sh, sorry. I'll just say sh space first script.sh and say enter. It says enter the value. I'm just giving something value as 100. See, it will print back the same value. Right? Second method, / first script.sh. When I execute for the first time, as I said that it doesn't have execute permission, it throw error saying that permission denied. So you have to change the permission chmod +x first script.sh. Now execute with the second method. Now it will work. The third method is source space specify the script name or dot space specify the script name. Is it clear, guys? This is the fourth method. So as I said earlier, whenever you're running sh space specify script name, that will also work. But what is this sh is all about? Sh, it is nothing but shell only. But what shell it is actually? Can you find out what is shell? So when I do where is sh? It says that the sh is nothing but /usr bin sh. Fine. When I do an ls-l /usr bin sh, when I do no, it is actually pointing to the bash shell itself. So whenever I'm calling sh, you're actually calling a bash itself actually. Can I see the same thing here in Ubuntu? Where is sh /usr bin sh ls-l /usr bin sh? It is actually pointing to something with a dash shell. Okay, there is something with a dash shell. Okay, so whenever I'm executing this sh, it is actually calling a dash shell to execute your script. Correct? It is actually calling a dash shell. Here, whereas here, what happened? Sh is actually pointed to a bash shell only. So I can even call like this directly for bash space first script.sh. Like that, I can call directly like that. Here also, you say that Rajesh, when I'm executing any shell script using sh, here in case of Ubuntu, actually it is calling a dash shell. A dash is also one of the type of shell, man. It also same thing like your bash itself, right? You can either call directly, you can call dash and specify the script name like that. You can call, or you can directly call bash and specify the script name like that also. Is it clear, guys? You can call directly the shell and execute it actually, and that is the best way. /usr bin sh we don't use, sir, because sh is but it's a bone shell. It's a old shell. We don't use it because we are working on a bash shell. Always you have to say /usr #/ bin /bash. That is what you have to use it always. Don't use #/ /usr bin sh. No, please don't use that. Clear? Clear, Ravikant?
Yeah, yes, sir. Thank you.
Yeah, please don't use it actually. Yes. Okay, guys. Chalo, today, we understood something about how to write a script, or else not really. I'm just telling you how to run a script. At least we have understood that, right? Now, any doubts here before we proceed?
Hello, sir.
Yes, madam.
So bash and dash same or different? Like Ubuntu, it's showing as a dash.
Correct. Dash. It's the same thing like a bash only, man. We have to understand that. Okay. That is a one more shell actually. It has same features whatever bash is, right? Dash also has. That is derived. The dash is derived by the Ubuntu distribution only.
Okay.
Like that, you have to understand. Okay, over. Fine. Okay, good. Now, okay, now the next question comes, right? Sir, what and all I need to learn about the bash? Yes. Now in the bash, guys, there are a lot of features are there. You need to learn or you need to understand about that features. It's very easy. It's not that difficult to understand. Very, very easy. Bash features actually. it is also very important whenever you're writing any script or something, like you should even have a knowledge of what are the features where your bash shell supports. Very important. Now, what are those features? So bash has many features. Okay, I'm going to just list out some 4 or 5 features so that will be helpful for us to better understand how this script works actually. Clear? Okay, you're leaving now? Okay, fine. Some of you are leaving now. Guys, I'll take another 15-20 minutes more, and then I will complete these features. And then, like again, as I said, like I need to go to my daughter's school for the parent-teacher meeting, and then like I'll be back by 11 o'clock so that we can start the class by 11:30. Is it clear, guys? Okay. Now, what are the bash features actually? Very important, guys. Bash features. So, what are the features? So, it says that command line editing and command completion. This is very important features. Then nothing. Then what are other things? We have a history command, aliases, job control, quotings. We say we have something as a variable substitution or brace expansion. Tilde expansion, variable substitution, arithmetic substitution, and something as a command separators. There are many features are there, guys, but I'm just noting on some few features. Like these are some of the features of your bash shells. So your bash works effectively because of these features. Actually, there are a lot of features. Other features are there, but this is one of the very important features actually. So shall we discuss about all these features one by one? It will take just some few minutes it will take to complete this, but very important to understand. Now, what do you mean by command line editing? Very important. Now, command line editing is something like, guys, suppose for example, if I go to some server like this, I'll go to this server. Suppose I'm executing, I want to execute some command, like I want to execute ls command. So I'll just say ls command. I want to execute a date command. I'll execute the date command like that. Now you will say that, sir, I want to execute both the command at a time, both the commands. So better to use always semicolon, ls semicolon date, and even some more command you want to execute semicolon who. So here semicolon will act as a command separator. It acts like a command separator. How the shell will do? Shell will try whenever you're executing like this line, shell will always execute the first command and then the second command and then the third command, right? So when I execute this command, can you see it is executing the ls command? You got the ls command output here. You got the date command output and you got the who command output. See, all these 3 commands have been executed successfully. Assume that you have executed this command, ls command semicolon. Instead of date, you mistakenly type data, and you have. So when you run this command, you will say that the second command has failed. It says that command not found, and then it has executed the second command. Now what happened, right? Suppose you are typing the commands. I'll just say semicolon date semicolon who. Now as a user, when you're typing it, now you realize that oh man, I have did a mistake. Instead of DATE, mistakenly have put DATA, right? So now what you will do, you'll take back your cursor over there, okay, and then rectify this and change it to date like this. This we call it as a command line editing. It means that within your command line, you can navigate your cursor anywhere. Now you might ask a question, sir, what is the big deal then? I know this, you can go back, correct. You can go back to any position within a command and you can rectify it. That's correct. But these features were not there in the other shells, in the previous shell. Like in the con shell and the C shell, this was not there. Once you type this command like this, suppose you mistakenly you have typed something wrong, no, you don't have a provision to go take your cursor here. You don't have the provision only. Earlier it was not at all there. Oh, once you have typed it completely wrong, again you need to retype it everything, guys. Again you have to retype it completely with the proper way. Like this. So in a command line, if you're doing any mistake, right, you cannot rectify the data at all. You cannot take back to the cursor. Whereas a bash shell, it provided this feature that, okay, you can take your cursor anywhere in between. Like, for example, I have executed this, I have typed this one. Now we'll say that, Rajesh, I want to take my cursor to the first command. I'll just say Control A. See, it'll take you to first line, first command. I'll say Control E. See, it'll take you to the last line, or it'll take you to the last command, like that. So these are some shortcuts. By using that, you can play around with the navigating with the cursor anywhere within a command line. So that's what we call this as a command line editing. Clear, guys? Command completion. What do I mean by command completion? Command completion is something like the shell has a feature where it will support for command completion. For example, suppose assume that you have a command, something known as a chattr command, change the attribute, right? Or else get attr, get the attribute. So this is the command, attr. This is the command, guys, actually. One of the command. What is not there? Chattr. Yeah, this command is there. Yes. Set attr. Okay, this is not there. So you have something like get attr or chattr. This command is there, or chattr command is there. Now what you will do? Now what you will do? Whenever I want to type the command, you will just say chattr, like that you will do. You need to type it completely. Why you have to type it completely? You have to say ch, and you have a tab key. You have to press the tab key twice. When you press the tab key twice, it will show all the commands which start the name with the name ch. You could see that chfn is there, chg password is there, chgrp is there, chmod is there, chh is there. Can you see something as chattr? Yeah, it is there. Now I'll press A, then again I'll do tab twice. It will show me all the commands which have start the cha. But I want attr. I'll just type T and I'll just say tab. It will complete that command. So it means that actually you need not to type it completely. If you type it halfly and use a tab key, tab will do an auto completion. It will complete that command. You need not to type it everything. Like for example, here I want to open the passwd file, etc passwd file. How I'll do? See vi. I will not type completely, guys. I'll say /e and I'll give tab. See, it will complete it. PASS tab. See, it will complete it. Even the file name completion or the command completion, everything is taken care by your bash shell, because bash has the feature of the command completion or the file name completion. It has this feature was not there earlier in the other shells. Conn shell was not there, C shell was not there. But later what happened, right? They even try to fix that also, because after the bash came, right, the Conn shell, the C shell, right, they changed it and they added this feature also, so that also support. But earlier, very long back, right, Conn shell, when I was working under the HP UX or IBM AX operating system, right, this command completion was not there. I have to type it completely, right? But whereas here, it has a auto completion. Is it clear, guys? This is very simple, but yet you need to understand this. Clear? Okay. Now, after this, what happened, right? You have something known as a history command. Very important, guys, history command, because every day, what happened, right? We will be executing a lot of commands, right? Guys, again, I'm saying that I've not yet come to the command. In the next session, right, after 11:30 session, we'll be completely concentrating on the commands only. And we will try to extend for some hours so that we will be completing a lot of commands. And then like we will switch to our writing a script actually. From by tomorrow, we'll be writing a script. But tomorrow, what happened, right? We will start with a very, very basic script actually. Tomorrow, complete one day, that is 3 sessions, right? We will be covering all the scripting aspect, but we will be writing a very, very basic script we'll write, so that we all will be comfortable in writing at least 4 line or 5 lines of script. We'll start writing, so that will be comfortable, and we will be understanding all the scripting programming construct, so that we can able to comfortably write any script actually. After that, what happened, right? I will give every day for every session, right? I will give two assignment, two script I will give you to write, so that you need to write and submit to me. Okay, so that I will get to know like how much you have understood. Is it clear, guys? So for everything, I'll be giving an assignment, small task. It's not like I'll give some heavy task. A small script, a small program statement I will give you, and I will tell you to write a script for that, so that you will be able to write a script and show me if there is any correction is required, right? I will even correct then and there itself. I will tell you. Clear? But you should start writing a script also now. That is what the main intention, right? Now, so now what is the next feature? The next feature is not but the history command. What do you mean by history command, guys? History command is basically it is something like where the bash shell stores all the commands, whatever you execute, right, into its own buffer. We call it a shell buffer, and that shell buffer is nothing but the history commands. So what the shell will do? The shell maintains its own memory or its own buffer memory, where all the commands which is executed by the user is in that memory, in that shell buffer or in that shell memory. Like for example, here, if I go here into my CentOS, suppose I'm executing some commands. Like for example, I'm executing ls command, I'm executing date command, I'm executing who command, I'm executing the command, calendar command. Okay, I might be executing lot of command, who are my command. So like that, I'm executing so many commands. Even I'm opening this file also, that it is a positive file. See, so I'm doing a multiple commands. So all those commands will be placed in your shell buffer memory. How to check that? What are the commands which are recently executed, guys? I want to run a command, which is history command. When I run a history command, you see here that apart from this, you could see that I even executed now recently. I execute chttr, get attr. I even execute the script also. See, all these commands, whatever I executed, right? See, everything will be there in your history command. It'll be there the history command. Now, usually, generally, what would be the size or how many number of what would be size of history command? Size. The size would be like 1024. It means that maximum of 1024 commands entry will be placed within your bash shell, but it is configurable. You can even increase up to 4096 also. Okay. Clear, guys? You can even store it. You can even configure to 406 also. It is possible, but by default, it is having a 1024 as a size. In some recent bash shells, they have increased to 4096 also. Is it clear? Now, whenever I'm executing any commands, all these commands, all will be present in your bash memory. Into the bash memory, it will be placed. Now the thing is that now the question comes, right, like guys, why I need this actually? Yes, this is very much needed, because whenever you're executing any commands, right, guys, you have to maintain the history of it, because tomorrow you have got stuck, or you are trying to understand, okay, I executed some 2 days back, I executed command, I don't remember what that command I executed. You just run a history command like this and just see, oh, what are the commands you executed. Okay, you'll understand, okay, this is a particular command I executed on that day. You'll get to know by going through this actually.
Excuse me, sir. If you want a command with a date, can I get to know, or it's not possible?
Date means actually basically here you won't get any date. You'll only get the
in
number,
history
serial.
we will not get. Is there any
Yes.
command because if I execute 2 days back, according to the date, if I get to know the commands or time like that?
No, you can't.
Is there any command?
No.
No, yeah. Okay.
So here what happened, right? You are getting a serial number, guys. This is the serial number for every command execution. What automatically shell will give some number to it actually. So the first most command which you execute for today was this command. The second command what execute this, third command, like that. It will show you that it will give the serially, and you could see that this will be keep incrementing, and you will see that 1024 it has reached, or 2048 406. So it will show you the number also. Like for example, here the date command is something like 400. So this is a serial number 400 it has assigned to it. Who has assigned? The shell itself has assigned. Suppose you want to execute this command, date command again. You can type this date command like this, or else you can give that serial number also 400. So to give it exclamatory 400 like this. See, it will execute the date command. So what the shell will do? Shell will try to search in the buffer Okay, which is that 400 or 399? You have to always give exclamatory and 399 and run it. It will execute that command. Now the thing is that actually, guys, whenever you are running any command or executing any command, or even the bad command also, suppose like you have executed a command by name data. This is command not found. Let us see whether the history command maintain even that command also. See, it is even maintaining whatever you enter, guys, it will maintain everything. Even though it's a wrong command, bad command, that command not found, still it will maintain an entry. Yes, correct. Hist file format, yes. Now what happened, right, guys? For example, here, why we need this actually? Because that, for example, whenever you are executing any command, okay, you remember that when I said, right, if you remember very clearly that whenever you're executing any command, so user is executing command, like for example, here, the user is executing the ls command actually. So here, a user is executing the ls command. So here there's a user by name Kiran. I'm just taking a name Kiran. He is executing the ls command now. He is executing the ls command. Sorry, he is executing the ls command. Now, always you know that whenever the ls command is getting executed, okay, what happened, man? ls command, whenever user is executing ls command, shell will always search for this command ls command. So with the help of a path n1 variable, you know the variable that the shell is going to execute the shell is going to search for that command, right? The shell is going to call the search for the command echo $path. You know that on the last class I told about this echo $path. With the help of this path n variable, shell will search for this command. But it is not always that shell will always search for the command to the path only, because what happened, right? Whenever the shell want to execute any command, shell will also first search in the shell buffer only whether this command is already executed. So how it will do? It will look into the history, whatever the shell buffer is there, right? Within that, it will try to check whether the ls has already been executed earlier. Yes, it has been already been executed. So what the shell will do? Take that shell from the shell buffer and execute it actually, so that this becomes very, very faster method. It becomes faster method. Correct? It becomes very faster. Or else what happened? There's one more level what the shell will do. Shell will also try to check from one more is there. What is that? Hash actually. Now what happened? Shell will also maintain a hash also. Hash means it maintains a hash table. So whenever you're executing any command, like for example, execute the ls command. See, ls command, what happened, right? You could see that the ls command, the full path is /user bin ls. Yes. And you could see that it is maintaining hit counts. 8 times you have executed. Now suppose if I execute one more time, this is the 9th time, this is the 10th time, this is the 11th time. Now when you execute hash, can you see that it has gone to the 11th time? So 11th time this command has been executed. So hash table is also maintained within your bash shell. Now whenever you execute any shell, whenever you're executing any command, whenever you're executing any commands, shell will not go to always to the path variable. First, shell will search whether that command has already been executed and it is maintained by your hash table. Yes, ls has been maintained. So if you're executing ls command, it'll go to this path and it'll go to the hash table and load this command and execute it. So again, what happened? Execution of any commands by the shell will become much more faster now, because the shell is maintaining something with a hash table. So you can understand something like hash is something like a key and value pair, something like that. You have to understand that, right? Here, what happened that it is maintaining the key of the number of hits with the whole command path. That's what you have to understand. So whenever you're executing any command, right, the shell will always search into the hash table also. Clear? It'll never go at the first time into the path. Suppose you're executing some command where it never founds that command even in the hash table. It never founds that command in the history also or into the shell buffer. If nowhere it founds, then only the shell will go to the path in one variable and search it. Unless and until the shell will try to always check first from the hash table and then from the history command table or from the bash shell buffer. Is it clear, guys? So now,
Yes. Rajesh sir, how many days this history it will keep?
so this will mean it'll keep it for some days, sir. Actually, it will keep it for some days. The history unless until you clear it off, or something like, for example, it keeps the details for up to 90 days actually. After the 90 days, what happened? It will flush that buffer. It will flush the shell buffer content.
So usually, when we stop and start the server, no. After that, if we do the history command, it will give only latest command which we executed, not previous, right?
All the previous. Like for example, here what happened now? Today I logged in, right? You logged in. You saw that today I logged in, but I have even logged in last station also, right? Last weekend also executed, right? So last weekend, see, all data are there here. See, not only even today's, in the last session also, you could see that I created a FIFO file. See, I created a run find command. See, I executed these commands, mkdir. All these commands are there. All the commands, whatever executed, even last week also it is showing everything.
Sir, all these comments are in bash history command, no, sir?
Bash shell, actually, yes. So hash will store temporarily. Yes, hash will store temporarily. When you exit out the shell, it will flush off the hash, actually. Yes, correct. You're right.
So what are bash profiles, sir? Bash profiles.
Yeah, coming back to that. I will come to that actually. Now what happened, right, guys? Now what happened, right? Now all these commands, whatever you executed, these commands, when I execute the history command, it is storing me, or it is showing me all the commands which are in the shell buffer. That is correct, right? Now whenever I say exit from this, I'm killing this shell. So all these commands, whatever you executed these commands, right? All the commands which are the history, right? That would be written, or that would be copied to one of the file known as a .bash_history. This is a file, permanent file, where all the, what are the contents you saw into the shell buffer, right? Or nothing but the history command, that will be written into the .bash_history. So if you go here, I have not exited, I will exit now. Now, if you do a ls with a -a option, you could see why you are using -a means all, means hidden. Even hidden file also will show it. So when I do an ls, you can't see any files which is starting with a dot. See, .bash_history, .bash_logout, .bash_c. You will see .ssh. These are nothing but hidden files or directories. Whenever any files will start with the dot, it's a hidden file. Suppose if I use a touch Ravi, I'm just saying, or touch dot Ramesh. I'm just doing Ramesh. And when I show ls, you see there's a file by name .ramesh. No, you can't see it. But because it's a hidden, you're starting a file with the dot only. But if you want to check all the files, I have to say ls-a. Now you could see that there's a .ramesh is there. So whenever you want to hide any file, whenever you don't want to display the file when you're executing ls command, please rename that file starting with a dot actually. Yes. Yes, Ram. So first, always whenever you execute any command, always it's first search in the hash table. If it never finds a hash table, then it will check in the bash history or bash path or the bash, bash buffer, or in the bash history, it will check. If there also not found, then it will try to look into the path. That is a sequence. Yes. Right. You're right. Okay. Now, so whenever any file or data starts with a dot, it's a hidden file. It's a hidden file. Right here, I created a Ramesh touch space .ramesh I created, so it shows a hidden file. So whenever you don't want to display, right, always you have to move that file with a dot as a beginning character. Now you could see that there's a file known as a .bash_history. Where is it file? .bash_history. Can you see it? Can you open that file? vi or cat .bash_history. See, you can see all the commands whatever you executed, right, in this file. See all this file. Now what I will do, I will exit out from the shell. As soon as I exit from the shell, all the commands what are there, it will be written into this file .bash_history. Enter. See, you have exited from the CentOS server. Now what I will do again, I'll go back to my this one. I'll go back to my AWS account. Select this CentOS. Go to the copy this public IP. Go to your downloads. Open the putty and load a CentOS and give the public IP and open this section. See, now you're logged in. Now when you try to open the .bash_history file, can you see All the commands has been written here. Open the file. Go at the end. Can you see all these commands which you executed now recently? See all these commands. See all these commands have been written permanently into this file. .bash_history file. Right? If suppose you are missing, somebody want to see what are the commands you executed, right? You can even open this file and see what are the commands you have executed. Commands which you have executed recently or which you have executed from last few days. Yes, guys, somebody has a doubt. Yes, Gopal, correct. Hist file size. Yes, correct. Now you will see that you will say that, sir, what is the size of the file or how many lines this .bash history can maintain it? It can maintain up to 1024. So how to check it if you have, what is the bash history file? You have to say echo $hist file. Hist file. It will say that under /home center there's .bash_history. This is nothing but a history file. This is the command echo $hist file. What is this $hist file or what is hist file? This is nothing but your one of the shell variable. Like how we the shell, right? Capital SHELL. Right? This is one of the shell variable. Similarly, one of the shell variable is hist file actually. So this is the command to check the history file. Correct? And what is the size of the file or how many entries it can maintain? Hist size or hist file size. Like that we can do. So it is showing 1000, but yeah, it could be 1000. Same thing, can I go and in a Ubuntu, can I run that command? Yes, let me check. Echo $, not here. I think I have to go to the Ubuntu here. Echo $hist file size. See, it is showing 2000 here. Yeah. So it is more here actually. In Ubuntu, it is 2000. Because CentOS is an old server, right? It's very old and they are not updated. Still, it is showing as 1000 only. But it is configurable, yes. Where it is, how it is configurable and all, I will discuss after some time. Okay, I'll show you a configuration file where you go and change it. You can change the value of from 1000 to 1024 or 2000. You can change it. What's the maximum? 4006 is a maximum, which you can change it. Actually. Is it clear, guys? Any doubts you have in the history command? So now what happened, right? You have a command. Sorry, you have a history command which will show you all the commands which you executed. This is in the shell buffer. Now you'll say, sir, I want to flush it off, sir. I don't want anything. I can do one thing. You can just say history-c. Clear all the things. See, you see, if I use up arrow mark key, nothing is there. If I execute a history command, nothing is there. Everything you've flushed. Again, you do ls command, date command, who command. Again, you execute a history command. Now it will show the latest entry, whatever you're doing. So now you'll say, sir, I want to write all the data, sir, into the .bash history. Whatever it is in the shell buffer, I want to immediately write it. I don't want to exit, sir, but I want to write into the history. So you have to just say history-w. It will write all these commands into your .bash history file. Immediately at the same instant, it will write into it. So guys, okay, now a small question to you. You can get me the answer after some time, not now. Why we need this concept of history file or why we need a .bash_history file? Can you Google it out and give me the answer? Not now, after some time, or maybe the next session, or maybe tomorrow you can get me the answer and give to me. Why we need this bash file or .bash_history? Why we need this file? Or what is the use of this file? Can you get me the answer tomorrow? Okay. Get me the answer tomorrow. Clear? So this is also one of the intro questions they'll ask. Why you need a bash file, .bash_history file, sorry. Why we need a file? Why we want to maintain a history of all the commands? Why it is required? Yeah, somebody might say, sir, I want to execute many commands or what are the commands which I executed previously. Somebody want to check it. Yeah, we need it. Yeah, that is one of the answer. Yeah, that's correct. We need it because we need to see like what are the commands you executed long back, like 1 week back or something. I can check it out. But there is one more reason for having this file actually. So you need to get me the answer for that. Clear? Just Google it out. You will get the answer, guys. Okay. So now, okay, shall we stop it here now? It is 8:45. Okay. So now what we are going to do now, guys, we will try to next session at 11:30 a.m. today. We will try to continue from here itself. Actually, here we'll try to continue. And what would be the next is after this, what we'll be covering? We'll be covering something on a login shell and a non-login shell. We'll talk something about the shell variables. What are shell variables and all? What is a internal variable? What is a internal variable? What is an external variable? What do you mean by exporting and all? We will be learning that. And then we'll be learning about some of the very important commands actually today. So in that command, we might even touch down with the set and awk also. To very basic level, we'll touch. Tomorrow session, we'll have some advanced options in set and awk also we'll cover. Plus, even in advanced scripting, we will be using set and awk in advanced scripting also. We have to even cover those things also. So today and tomorrow will be a very, very important for us because we will be covering main core of your complete scripting will be covering by today and tomorrow. Right? Today, at least, if not today, at least by tomorrow morning, we'll be starting the scripting part. Very important, actually. Clear? So we will be learning these things, and plus we will be learning many of the other commands and all. So we will be, and also like we will be covering about the some important options in Aviator also we'll be covering today. Means in our next session we'll be covering that. Is it clear, guys? So this will be the agenda for our next 2 hours. So we are going to start at 11:30. So 11:30 a.m. to 1:30 p.m. or else I might go up to 2 o'clock or so. Okay, fine, guys. So then we'll stop it unless until if there is no doubt, we can stop it now. You don't have any doubts, guys? No?
No, sir.
Okay, thank you. Thank you all.
sir.
Then,
Bye.
yeah, correct, Ram. You're right, actually. To reuse the previously executed commands, we use the history command. Fine, that is good only, correct only. Is there any other things which you can find it out? Please find it out and let me know. Okay.
For the execution speed, sir?
Yeah, that is there, right? That's correct. For execution speed, you have that actually, but yeah, shortcuts to follow the view, modify, delete bash. Okay, fine, that is correct. What you said is right. I'm looking for some other answer actually. If you get it, actually, it'll be good actually. Otherwise, I will discuss that. Okay. Fine. Okay, guys. Chalo then. Let me stop the recording. I'll stop the recording.